We are live.
Okay, what do I do? Can you send me a link? See if you can send me a link. If you can't, I'll go live too.
Testing 1, 2, 3, 4, 1, 2, 1, 2. Tim Johnson. How you doing, Mr. Johnson? Let's see. I gotta go into my sound card. Here's my microphone input. Okay. Testing. 1, 2, 3. Hello. This microphone sucks. Yeah, this microphone sucks. It's on
I
now.
can't hear nothing on it.
Testing 1, 2.
Yeah,
Mr.
there you go.
Mr. Johnson, can you hear me?
Johnson, can you hear me?
All right. That don't sound too bad.
Can you hear me, Tim?
I hear you
Johnson?
fine.
What about Tim Johnson on there? He's asking me a question about the tooth. I can't tell if he can hear me.
Mr. Johnson, can you still hear us? Okay. Yeah, you can hear us. That's awesome. I appreciate the help. Okay, we're up.
Yeah, if I made a live on mine and we did it this way, it would just echo back and forth real bad.
Oh, so we're probably better off this way then, for the
Yeah.
most part.
Yeah. Unless we want to pay a ton of money to do that, that's kind of crazy.
Yeah.
Pay all that money.
Yeah. So what do you want to talk about?
I don't know. What's that on your bench right there? The open circuit thing.
Oh, this guy here.
I can't see anything. But yeah, that box. What are you doing with that open box right there?
Yeah, give me 1 second. I'll turn it on. What it is it's actually a it's very sensitive audio amplifier. So, and what I'm using is it's a 60 hertz receiver, and there is
yeah, you're doing something to the camera. You're distorting something when you hooked it up. I could hear the interference.
Yeah, this is. I'll turn the volume up so you can hear it. But this is the end.
Whatever you're doing, whatever you turned on is messing with your camera and all kinds of stuff. It looks. I don't know. Your audio started wigging out when you turned it on.
Really? It's off now. Everything okay?
It seemed like it. Yeah, it started changing. It may have been that wheel. I don't know.
All right. So this is the antenna. There's almost 1,000 turns of number 38. I think it's number 38 wire to pitch to wind. And it was like, it's so thin. It's almost broke it twice. I thought I broke it, but anyway, so almost 1,000 turns of fine wire as hair, fine as hair. But this is resonant with a 700 UF, almost 700 UF. This is resonant right around 100 hertz, or a little less. Probably like 70 now. What
caps are you using to pull that off? What do you got? Some power correctors or what?
No. This is just a loop antenna. It's all it is. It's just a loop antenna. So this is just ticked up, but there is a big chunk of wire. There's.
Oh no! I mean, what are you using to resonate that with a capacitor? What capacitor are you using? The 700 UF?
Yeah, no. I've got all the capacitors under the tape.
That's a big AC cap. That's a pretty big AC cap.
Yeah.
I think my biggest one.
Battalions.
Is 260.
Yep. They're all in there. There's a lot of them in here, but that's what it took to get it resonant.
Yeah. You listening to some submarines or what?
No. This is really sensitive around 60 hertz. Yeah. 60 to 120. So, if I right behind me in my backyard on the back side of where I'm at, there's high tensions, and it's funny because the high tension line goes this way, and this for maximum signal off the high voltage wants to be orientated like this. So axis is this way. So when I can actually literally null it out, and it's the power lines behind me is only about 200 feet away, but it's interesting that I turn this sideways and I can literally null that whole thing right out. So it's very directional. And what am I going to do with this? Just to try and find or locate power lines under the ground that are buried. That's all. originally this was built. I have on top of this cover. It's stuck out of the back here, but there was a coil that I had on here that was on a ferrite rod. I think it's probably right around 300 ohms. But I mean, I could hear magnetic disturbances right around 3,000 hertz. Interesting to hear. Listen, the lightning and stuff.
Mm-hmm. Oh, that reminds me. I don't know if you want to talk about it yet, but what about the detector it's talking about?
Oh, the gravity detector. Yeah. So.
Yeah.
I'm definitely gonna make a. I spent literally all day today trying to find the one I made 15, 20 years ago. 20 years ago. And I still haven't been able to find it. So I know I have it. I just got too much stuff.
Yeah, I'll be right back, Tim. I'm gonna go get the parts I got for that.
Oh yeah, sure.
Yeah, the bag of parts for this. So I got the laser, the spy laser, and the gravity detector and the buffer stage. I got both of them. The buffer stage and the first stage of op amps and stuff, and it was $78, and that was just for Mouser for the parts.
Really?
For the laser and the it was expensive. The gravity wave was those op amps were not cheap. I can't remember what they were though. Let me look at I think it says the price on this page. Maybe.
Mr. Johnson, can you hear Heliarc? Okay. I don't know if he's still here or not.
Oh, he's there.
Yeah.
You gotta scroll down.
Cool.
It's not letting me scroll down very easy. There it is.
Yeah.
Oh, he asked would it work on a metal detector?
Yes. Well, no.
The coil.
Maybe. You're probably better off winding your own coil for a metal detector. You can probably do better than what you can buy off the shelf. But that loop that you just saw on there, Tim, is just for finding power cables under the ground. I'm just trying to make that sensitive enough to pick up something that's buried 20 feet in the ground for power lines.
Yeah, they didn't put the price on here, but yeah, because I had to get a timing chip. There was a special timing chip in there. No. It was the audio volume control. Yeah, audio power amp, audio volume control. I think that's for the laser. Yeah, because I'm building the spy laser too. Because I have a million lasers laying around, so I can do it with. I'm gonna do infrared.
Yeah.
That one. I'm gonna do probably 964 or 1064 nanometer because it's invisible. And yeah, I didn't even make a video about that, about the spy laser. That's old technology too.
Yeah.
Where you just shine the laser at anybody's window with a telescope. You can put it on a telescope, so you can be like miles away potentially. I don't know if it would work miles away. I know it would work for a long distance.
Yeah, I had a Celestron. The one I made for law enforcement up north. It had I used a Celestron telescope. I think it was 3-inch. Yeah, I think it was a 3-inch one, 2 or 3 inch. And I use that to zoom in. Most of the time, when you're doing that kind of stuff, you want to position yourself in such a way where you know you're going to get your return beam coming at you. So you really want to be 90 degrees to that thing. I mean, zero bubble to the window, so you can get what's coming back, because there's two ways of doing it, and that's having a slight V configuration towards the target, or you can have it coming right back at you. You know, be the next.
One target.
Yes, and that's the
Yeah.
best way because that's the most sensitive. So what you do is when you're coming back with that, to basically you can overload the front end so much because of the direct beam. You use another LED to diffuse, and then the whole sensitivity, the whole place comes up. Like literally, if somebody knocked on the front door of the house and you got the beam on the back window, you'd hear that knock on it. You'd hear everything in that house. Everything. People walking around, talking, everything. The house is a giant microphone.
Yeah, I figure it's real sensitive.
Oh yeah.
I know they have a system now too that doesn't even need a laser though. They just use a camera. Really, I think it's an 8K or a 16K camera, and they can put it on a drone. They can put it on anything, and they just hover it, and it'll look at the grass or whatever objects around, and it can actually measure the vibrations off of the camera. So it doesn't need a laser at all. It can do because the cameras are so high definition now. You can pick it up.
It's kind of crazy.
Yeah.
Crazy sensitivity there.
Yeah. Well, think about it, Tim. The laser that was in the 80s. I mean, they came out with that in the 80s. Like it's not a stretch at all.
Mm-hmm.
So 40 years later to have it on a camera, to me, you know what I mean? You would think they probably had that 15 years ago. So, yeah, that's pretty cool, man. It's cool. A lot of people don't know that kind of gadget exists. The laser.
No, that's like
I have no idea.
I forget the name of the embassy in Russia, American embassy, that we were building a new one. I don't know if this was in the 70s or the 80s, somewhere around there, but the concrete that they were getting to build a new American embassy in Russia was come from a concrete company right there in Russia. So the Russian government said, "Oh, okay, yeah, we'll help you every way they can," and they did. They helped them with all their resources that they needed, but a gazillion microwave diodes in the concrete mix was yeah, that's what they did. So you point microwave feed horn at the building at low level. It don't have to be much. And all you're doing, you're lighting up all those LEDs, and they're modulating the sound vibrations, and it's coming right back at you. And you could focus in on any. Supposedly, they could focus into any part of the embassy and hear any conversation they wanted to. Even to the
shit. I thought it would be to fuck with people.
No.
Like,
even to the point where they started to realize that they had processor noise coming back. And somebody got the idea of, well, if we got computer processor noise, let's see what we can do with that. So they were like literally seeing what was on their screens inside the building, what they were typing, just through processor noise. Yep. Not many people know that. Yep.
That's wild. I didn't know that either.
Yeah.
They were that clever back then. You know, there's really no telling how much advancements they made because they kept it quiet like the Cold War. But they had some amazing stuff in the 80s that really kind of blows your mind today that you just didn't know about.
Oh, yeah.
Yeah.
I mean, like the gun diode is nothing. You could take a gun diode and literally, I had to walk away from the door from this for a second. You could take a gun diode and literally put it in a tuned cavity and put a little power on it, and it'll start oscillating. But it also does the same thing in reverse. It'll also receive. So if you have the gun diode set up on a flange going to a feed horn, and you have that pointed towards the building, and you just have a raw microwave source blowing at the building, that gun diode is going to pick up all the sounds. So you're just going to pump that right into an audio amplifier, and you're going to hear everything.
Yeah.
Yeah.
Wow. So many ways to skin that cat. I know they can see you through the Wi-Fi too. They have sensors now they can put on the wall pump, and they can do it from a distance, but they can put it on your wall on the outside, and they can either pump the microwave in, like the Wi-Fi signal in, or they can use your Wi-Fi in your house to triangulate you, and they can actually build an image with it.
Right.
And they can actually take a damn shot at you through the wall.
Yeah.
And because they can see where you're moving, where you're pointing, where you're going, everything. Just like almost as if it's like an infrared image. It's just a bad one, like a bad infrared image, but you can still make out shape. So, what do you got going on there?
I don't know.
Is that like a mirror trick?
Yeah, a little video feedback. Mm-hmm.
It's like looking into a mirror, right?
Yeah. That's kind of cool. Hope I'm not making anybody throw up. Hey, Mr. Johnson, where are you from?
Oh, I think he left.
Oh, did he?
He might have, because it says it's one person watching now, but I think he's been popping in, because I'm one of the ones watching, I think. I think it's kind of me, but people will come and go.
Yeah.
And if this is, are you recording this to your channel?
I believe I clicked the DVR part, so it should be.
Yeah.
Yeah.
Oh, no, I guess he is in there. Maybe it's not.
Oh, California. Okay. So where's Doug? Doug is in Seattle. There, he's not too far from you. Not too far from Doug.
Yeah.
Appreciate you stopping by, sir.
Yeah, I'm scared to name it what we were talking about earlier, but with the plastic in between two plates, I really want to try that, but because my father has a bunch of old HTH buckets. They're the perfect plastic according to H.
Oh, really?
They don't have the titanium dioxide in it. Yeah, they don't have titanium dioxide. The only thing is, though, that it's not, I think it is, maybe it's polycarbonate or polyethylene or something like that. I think it's polyethylene, but the PTFE, yeah, it doesn't have the titanium dioxide.
Yeah.
But they put titanium dioxide in Lexan, so you can't do it with Lexan. The effect won't establish with titanium dioxide present, which is probably why they put it in there, and they probably have other bullshit reasons, but H was saying that that's why they put it in there. They put it in glass even. So, and I did some searching after he told me that, and I was like, oh, damn, they do put it in Lexan. I was like, I didn't think about that, because Lexan's pretty high on the dielectric constant index. So I was like, that'd be a good one, and I got plenty of it, stored away, but, oh, and another one is nylon, Tim.
Yes. Yeah.
Nylon works good, and I don't think it's got it in there.
You know what?
It's expensive.
If you want to know if it's a good dielectric or bad, put it in the microwave for 2 minutes.
Yeah.
If it survives that and then it's not warm when it comes out, then it's a good dielectric, definitely. It's like PVC pipe. I see people, PVC is like, there's some frequencies that it interferes.
Yeah, it can, some kind of skin effect,
skin-like
effect. But yeah, so if you take two plates and then you melt your Teflon, because what you do is you heat the plates, because say they're aluminum, right? Or it doesn't matter, it can be stainless, and then you put your plastic in between, you heat that. You don't want it to short, but you set up like 20 kV field. You just want a good E field, and you set it up when that plastic's melted. It's got to be at the right temperature, and I'm not sure what that is with different plastics, but Hector said it's just got to be hot. And then once you establish that E field will align the ions in that plastic. And what happens after that is it becomes a dielectric magnet, and that's like a new one, because you don't hear about it unless you're an audiophile and you actually know about the microphones they make with them and the headsets that cost several $1,000s, because they're so good. Like, they're so good because of the techniques they use with that specific technique, that they're like $3-4 a pair.
Mm-hmm.
Headphones. So but you can make it. You can make it out of glass. It has to be the old glass, the power line glass, the insulator glass.
Yeah.
That doesn't have titanium dioxide because it was short. If it did,
Green glass.
H said they put it in there because it was short.
Yeah.
So you can't create the the I'll go ahead and say it's the electric. I can't even pronounce it. Electric.
Yeah.
Electric. Yeah. So, but once you get it established, H was saying it could last thousands of years. Like you could perturb it, you could keep perturbing it, and it was the same device that Greer showed in his film. Was the electric that with the plates that actually there was glass or plastic in there, and all he was doing was tickling those plates with a certain code, which is just a resonant. He probably had time to where it would like do a kind of dance in there. You know what I mean? You could time it with an Adreno, but that's what looks like. What that one video I sent you, it looks like that was what he was doing. But he was powering that helicopter headlamp. It was like I can't remember, 400-watt lamp with that thing. And a 12-volt, fully charged 12-volt car battery wouldn't fire it.
Wow.
He demonstrated it. I sent you the video, I think. I downloaded it too. But, and that's not the same guy that Greer had on. It's a different guy. This was, he was some engineer or some high electrical guy, and he was an older guy. And yeah, he had it set up, and the voltage never went down. And he also said a voltmeter won't detect it, or it will, but it oscillates. And what else did he say about it? Oscillates. Maybe can I drop a link on this? I don't know if it'll let me do it. Let's see if I can find it. Yeah, that was good, man. No, that's not how I do it. I gotta go
6 hours from Hutchison. That's right, too. Hutchison lives up that end. Have you ever met Hutchison there, Johnson?
Got it. All right, now we go back to your live. So that's the video, man. If all the viewers, if you see that link and you can click that link and play that, you should watch it, at least save it, because he's going to demonstrate that helicopter light, and there's another guy there with him, and he's watching it. So it's fucking interesting, and that's what it is. It's an electric, whatever. It's the dielectric magnet, and it's actually it's basically gravity replenishing it, but it's the sun's ions that's all constantly being replenished, because half the Earth is always bathed in it. So it's even if it's dark outside, the guy claims it's solar powered. So, and it probably is. He's probably right. It's the same thing that charges the radio tower you want to buy, Tim.
Exactly.
Yeah, it's the same thing that charges that dead radio tower that somehow has got all this fucking magical power on it. Like it's isolated from the ground, and there's like no telling what 20 kV up there.
Shit,
at what,
probably
400 feet. How tall are those? How tall? How many feet? 300 feet.
Yeah, well, I mean, the ideal AM tower, I think, is 1,000 feet. You know what I mean? Or 2,000 feet. I think there's one in Florida that's 1,500 foot, and that gets out. But the biggest problems with AM towers is they're not long enough. So they've got these big tank circuits that they've got to make up to keep the VISWA down low enough so they don't blow the transmitter apart.
Right. But yeah, we could still do it because there was a video of a guy doing it with a drone. He took his drone and he pulled the wire up. I think he had a little plate on it, like a collector plate, and he flew it up there. And he was powering a static motor.
Yeah,
dielectric is static. That's all it is.
He did. I saw that video, and when he got poked, I mean, the guy almost jumped 5 feet.
Yeah, no, that's the same power you're talking about, and that's the same power too that those plates are creating.
Mm-hmm.
It's the same, and it'll shock you differently. Like everything about it's different. Yeah, it runs a little colder for some reason. It like filaments and bulbs don't get as hot but it'll be bright.
Interesting.
Yeah, it'll still get hot, but it's not as hot as normal electricity. So it's kind of strange. Because I know he said that bulb will get hot if you have it on an alternator, but it didn't get as hot on his battery, but it would still light it up.
Mm-hmm.
And even if it's not at full power, it's pretty crazy that he's able to light that bulb up. And H said if you make one of those, all you got to do to convert it is get you like a high voltage transformer, and you got a either spark gap or switch into that transformer with what you're collecting, and then collect off your secondary, step it down, even if you got to step it down twice, because it's already free. Who cares if you got an 80 or 20% loss at that point? Whatever you're collecting is free anyway, because it's being automatically replenished since the plastic is polarized. So it's always wanting to keep a difference on its plate.
Yeah.
And what's crazy is that was discovered over 100 years ago, or postulated over 100 years ago. And it was kind of suppressed because they put a national security order on a guy like that. You guys want to get a visit? Build one of those and talk about it on YouTube. That'll get you a visit. If I build one of those, I ain't telling nobody. I ain't.
Yeah.
I probably will never build one because it's. I don't even want to have one in my house, to be honest, because that's one that'll probably get you in trouble. Yeah. Yeah.
The
do it, but it's probably going to be at a later date. Yeah. For sure.
I think
Rich, that name sounds familiar. Rich Frederick, it sounds familiar to me, but I think I've watched it. I think I see his face when I hear that name. I think I see his face.
the Friedrich guy.
Rich,
Yeah.
Yeah. Yeah, I think I've watched something. That name rings a bell.
I've watched a lot of his stuff. It's tough to I'm sure he's a nice guy, and I'm not trying to shit on him by any means, but sometimes it's tough to listen to it because it just takes too long for him to get what he's a smart guy, so he gets sidetracked with his own conversation sometimes. He's talking about one thing and he'll move to something else, but it's only to reinforce what he's saying. So
yeah, I do the same thing.
Yeah. We all do it. Everybody does it. Sure.
Yeah. Tim, why don't you tell them about your, if you don't mind, tell them about your very first, the little window motor. Remember the one you had under your bench?
Yes.
Do you want to talk about that or no? That was a long time ago. And you don't have it.
Well, it's in pieces. The only thing I don't have is the magnet rotors. I still have the coils.
Yeah.
I still have
was
the
it,
coils.
800 milliamp?
No. It was I was getting an amp out of each one, usable power out of each one, 1 amp from each one. So it's 2 amps total.
Okay, that's right.
Yeah. But they ran at opposite polarity, so one was negative ground, and then the other one was positive ground.
Yeah, there's one part you should leave out, and you know it.
Yeah. So they were opposite motors, and basically taking the back EMF from one to run the other one. Yeah.
That was man. I wish I wished I'd have kept the DC, because I had a 3-horse or 2-horse DC motor that was so. I showed you a picture of it. Remember, I got the magnets and I chipped one, but I wished I'd have left it alone, because that thing, man, it generated good power when I was playing with it. I was like, that's actually pretty nice, even though I had brushes. Because a DC motor, you can actually do a lot with it because it's got brushes,
right.
So you don't have to have a driver. You can resonate it right there. You can do a lot right there at the. And Hector, I know I've never done this, but Hector always talking about wiring a DC motor to Y. Wire the because at that point it's the rotor. You got to change the winding of the rotor to Y, and I think he talks about it on an EV Grade. There's a bunch of posts where he's talking about it if you search it, and yeah, it's very interesting. So, yeah, I don't want to shit on what he said about it, but yeah, everyone can read it. There's actually a lot that people could probably go read right now that they don't realize they have access to, that they just don't know about.
Mm-hmm.
They probably shit their fucking pants. I had one guy that messaged me. And I didn't really tell him much, but because he said, what about UV Gray? And I was like, yeah, you need to go read. And then he came back like 2 days later and he's like, holy shit, was that a gold mine? And I was like, I told you, yeah, you need, because H is only 73, like, you know, he may only have a couple good years left where he's able to do this. So, and he's active. He'll talk to you. Like if you ask him a question, it might take him a while, but he'll get back to you with something. But you gotta, and people gotta think about how he talks too. H is very short with what his answers he gives you, and it's very, you gotta think about it. Yeah, you know that, how he does the jokes, and then he'll give you information, but it's like just bits and pieces of it.
Yeah.
So, but not all of it. His diagrams are still up. His rotoverter's still, he's got a website dedicated to it. With his picture and everything on there.
Yeah, when I was building those window motors, it was like you can only really go. I mean, ideally, I think a window motor should be a 6-pole magnet rotor. I think that's the best.
Yeah.
But initially, those two, I always wanted what it would be like if they weren't 2-pole. They ran fast.
Yeah. I mean, I guess you're bound kind of by your magnet, right?
Well, yeah. I mean, in a window motor, you want one polarity on one side of the coil and the opposite polarity on the other side of the coil. So.
Well, you're talking about 4.
When you can't do 4 poles on a window motor.
Oh, okay.
Yeah, because it's like if this is the if this is, let me get this keyboard out of the way. If this is your window motor, and your coil's going around here, so you want one polarity this way and the other polarity that way. If you have a 4-pole, you're gonna have north. Yep. You're gonna have north this way and north that way. So 6-pole is ideally the slower running, less wear, last longer. And then there's more of an anomaly that takes place when it's 6 poles. It's a rough one to grab when you're 2-pole. You know what I mean? To get within your resonant RPM. And then the other thing is the magnets were. I use the magnets. I'm going to use your rotor that you 3D printed for me. The arc magnets were literally like that. As a matter of fact, wait a second. I don't know if I can dig this out.
Yeah, that's a 4-inch rotor. That rotor's 4.
Yeah.
I remember.
But I want to show you something. Yeah, so this is roughly the size of what it was. So looking down.
Well, that's a nice one right there.
Oh yeah, it's already set up on the shafts with the bearings and everything. But this is the problem. This is north this way, south that way. If you had 4 poles, then obviously you're going to have north, south. So you'd have the wrong spot. So 6 is the best. And it would obviously it'll run slower. You know what I mean?
Right. Yeah. Is that what you had on the other one, on the old one? Or did you try it later?
But did I what?
Did you have 6 on your old one?
Yes. Yeah. No. I wish I did. It was just a 2-pole. It was like this. So I had 2 of these. Yeah.
Okay. Yeah. Gotcha.
But if it was 6-pole, that would have been. I probably would have got more current out of it. I only got 1 amp from each one, so. Yeah.
But that's still quite a bit. That's still quite a bit.
Yes.
When it's constantly running for 2 years. Yeah.
Right. Yep. Yeah. 24/7. 24/7. I
Yeah.
never, and I had it was right underneath the bench on the bottom shelf, and I and that was one, two, three, that was four, yeah, four 6-volt golf cart deep cycle batteries. So yeah, 200 amp hours. So that was 400 amp hours of battery that I had that was always ready and charged 24/7. I had a 10,000-watt inverter hooked up to it. So whenever the power went out in the house, I just turned that sucker on and throw the switch and cut the grid off and call it a day. And I'd have power.
Yeah.
Get
I
me.
wanna, maybe you'll talk about this too. I'm picking things that I think you'll talk about. What about the bit and the inverter when you had that outage?
Oh, yeah.
It was kind of recently. It was a few months ago.
Yes, yeah. I was absolutely amazed. And
Tell them about that then, Tim. Tell them about that.
It was something that I always thought about doing, and it's like I always wondered. I'm walking away for a second, just hold on.
Oh, this is good.
I wondered.
And then I got another story for you to tell that they'll like after this. Just wait. That you'll want to talk about.
Yeah.
Remember the 2 plates and the shampoo or the conditioner? We'll get to that later. But yeah, there's the bit. Okay, do the bit.
Yeah, another time. So this is what I had. I got the shunt bars down there, so I had the bars on here. And as a matter of fact, this is the one that this is the 3-phase transformer that I had ruined, trying to tweak it to get more out of it. So this is, I don't know if you can see. Yeah, I can see this on the screen.
Yeah, the camera's not bad. You're not bad.
So this was the original thickness on top. And I cut this much off and then had this thing sitting on the belt sander trying to true it up so it was, sitting nice and square. So right now, with this the way it is, it's back to what it was.
You fixed it.
Yes, yeah. So
Nice.
it's as good as it was before. And so that when we lost the power, I threw the shunt bar on here. So it's the complete opposite of this. So I had it turned on this way. And I realized that it actually acted better when it went straight across like that. So that would be like this.
So you had no bar on top?
I had a bar. I had a bar on top.
You did have a bar. Okay.
But they weren't hooked so that they'd be standing out here and it was close. So this was the gap. This gap right here is like, I realized it's better. So this is all you need for a gap right here. And as a matter of fact, I've come to the conclusion, I've got some key stock at work I want to cut up. I think, when the back EMF is disappearing into this, who cares if you have eddy currents in here? The eddy currents are going to chew up the back EMF anyways. You know what I mean? Because with the bit, every half cycle, your back EMF is doing this. Just like that.
Yep.
You know what I mean? Every half cycle. So some people think that it's this way and then this coil is doing that, and it's not. Everything's uniform. Yep.
Yeah, I see it the same way. Yeah. When I looked at the bit, that's exactly what I see.
So this one is good. So, but anyways, getting back to what I was doing. So I had I took a 12 volt 120 volt true sine inverter. It's only good for 600 watts, but that's all I need. So I drove this and then this was these 2 coils. I was driving the middle. 2 coils are resonated with the 10U F cap. And then so I was taking this power out and I was taking that AC out and going right straight to a switching power supply to charge the batteries. So this ran separate from everything else. And then I used another inverter pulling off the battery bank to give me power for work, for a load, to run things, TV and fans or whatever. This ran independent and it kept the battery charged. And when I mean it kept the battery charged, I used the thing for 3 days and I only lost 1.5 volts. That was all I lost. Maybe 2 volts at the end. And I mean maybe. And that was only because I think the refrigerator came on at that point. And it just shut off, so it was trying to catch up when I finally killed it, But that was that kept it going. That kept it going. Yep. I was amazed.
Yeah,
Because my backup plan was to run another inverter out in the vehicle and run the cord in and charge the batteries off charge the battery bank off the vehicle. You know what I mean? But I never had to do that.
Yeah. That's pretty cool. Oh, and let's talk about those plates you had in your shop that you had an engineer tell you about some kind of conditioner to buy, and then you got that sponge thing. Do you remember that?
Oh yeah. There was so stainless steel and aluminum, I think it was. Is that what I said? Got it all written down somewhere. And I forget what shampoo it was. I forget what hair conditioner it was. It was for perms. There was something in there for perms. Anyways, I soaked this ShamWow pad that I used in between the two sheets, sitting on a big table. Yeah, that was crazy. And you could short that out and short it and short it and short it and short it, and it would just last forever. It was just like a big battery.
Yeah.
But there was...
Yeah, because I think you said you charged it to 12 volts or was it 6 volts or 12 volts, and then you let it sit for a long time, and then you could arc it.
Yeah.
And it was like a welder almost. Like
right.
It had so much current. But I think you said it was a 4x8 sheet.
4x8 sheet, yes. Yeah.
Yes, it was a big ass sheet.
Yeah.
So you made a giant fucking capacitor with some kind of air conditioner.
Yeah, but
for perms.
It had to be level because I ground up activated carbon until it was pulverized like powder. And then I used what the hell did I use with that? I used something. Anyways, I coated the whole sheet with it, let it dry. So it was a carbon film on both sheets facing each other before it went on the mat. And that was kind of a pain in the ass. I remember doing it because the table had to be perfectly leveled, otherwise the shit would just run right off somewhere. I had this masking tape flipped up on the side to go all the way around the sheet for like a little lip so it wouldn't run away until it dried, and it was a pain in the ass, but it was amazing when it was done. And my plan was, and this was up north in Maine at a friend's place in his barn. And this guy was hanging out up there that was doing stuff that we were doing, but he was doing it up there. And he wanted to get into the electrosmog collection. And so he does that up there. And he's also has a, I forget what coffee maker, K-Cup coffee. And this was when I first came out, but had stainless or titanium. Oh no, I changed the probes to titanium. I got some titanium welding rods. And anyways, that's splitting water, running a Honda generator. That's how he does it. Most of his power is big power. He does it that way. So he runs a generator, and the reactor is only this big that's running it.
Wow.
Yeah. Yeah. Still to this day, he uses the thing. It's still going. Yeah. And that's got a plastic gas tank on it that's just full of water.
Yeah, that'd be nice. And I think I sent you the videos of this guy on YouTube. I think his name was Algernon. I don't know if he's still got the videos up, but because I tried to search him and I downloaded the videos, but he was resonating water, getting a reflection at a specific frequency to where it was drawing almost zero current, yet he was still producing hydrogen. But it wasn't very much hydrogen, but it was still producing. What are you showing off there? Relays?
This is, I'm trying to use the camera to see what the frequency was. Oh, 20 to 20. So this is 20 hertz to 20,000 hertz. It's a audio transformer.
Oh, okay.
Yeah.
Nice.
Yeah.
Man, you got so much shit in your garage.
This is.
Shed.
These
you need
are.
like one or two of those plastic sheds you just stake out in the backyard. That way you can make your garage a full-on lab.
These were in the box. So these are brand new, and they're probably close to 70 years old now.
Damn.
Yeah. Yeah. Got a lot of stuff. I have a lot of stuff like that. Oh, that's what I wanted to show you. I don't know where the hell I got these things from, but let me see if I can open this up. Oh yeah, there's tape on it.
What is it?
It's a tiny little spectrum analyzer. Look at this sucker.
What?
Yeah. I'm going to turn it on just so you can see it.
Has it got a little baby screen on it too?
Yes. Yeah.
Are you shitting me?
No, I shit you not.
I gotta see this. I gotta see this.
Yeah.
I put it on full screen. I gotta see this. Oh yeah, you got 1080 HD on your webcam. That's good.
Yeah. I haven't used this thing much. I forget what the voltage.
How much was that thing?
I don't know. I bought these things
What do you
like.
mean you don't know? Your eyes sound like me now.
Yeah.
I
don't know. I bought them.
Remember how many I bought?
Bought them like 10 years ago, so I have no idea. It's like every time I open up a box, and it's like, holy shit! I don't remember getting this. It's like Christmas time every day.
Shit.
It's a little tiny little spectrum analyzer. So there's my internet connection right there.
Some hacker's probably like, "Oh, you dumbass." I'm just kidding. There's not that many watching. That's cool.
Yeah. So 2.41, 2.51. That's the whole 2.5 spectrum. Yeah.
That's like a little bigger than your thumb.
It is. Yeah. Well.
Not really.
Shit. What can I do for?
That's crazy. That's like looks like a little bigger than a square inch.
Well, hey, you know how big around that was because you sent it to me.
Inch and what is that?
It's
inch and 3/8. It's inch and 3/8.
Yeah, I think it was. Yeah. So this is I think it's inch by inch, inch and a quarter maybe.
Yeah. There you
Yeah, inch and a quarter, inch and an eighth square, tiny little thing. There is a spot to put an antenna on there, but that's just reading, just catching it. Yeah, it's pretty amazing, huh?
Dude, I gotta have it. I gotta look for that now.
I haven't seen them anymore. I got the next time I said something your way, I'll throw one in there.
Oh, how many do you get?
I got 3. Actually, I got 4.
Oh, shit.
Yeah. Yeah.
I already got a couple ideas for that.
Supposedly you can change this. You can go in, you can get into it, and you can change the spectrum on that. I don't know how far.
Sure you can.
I don't know how far high up, or I don't know if it goes higher or lower. I'm not sure.
So I wonder, does it just sweep?
Yes.
Or what?
Yes. Continuous sweep.
It just does like a little sweep.
Yeah. Let me get this in here so you can get a really good view of it.
Okay. Yeah. So when you turned it on, it probably took a short sweep, and then it just said, "Okay, that's your Wi-Fi. I hear that, so I'm going to play that."
Yeah. So I'm going to power it off.
That's what.
Power it on.
Yeah, I see.
Pretty amazing little guy.
You could use that as a bug sweeper too if you had an antenna on it.
Yes, sir.
That was sensitive.
Yeah.
You could definitely should be able to sense it if you approach the bug.
Yeah, so it's a neat little item. And I had originally. Oh, I know why. I wanted to. I used to ride around with a Linksys router that I had reflashed and configured it to automatically find open access and connect to it. And then once it connects, it would line up another one. I don't know if it was Rotten Tomato or I forget what firmware I had in there. And then the routers, these particular routers, these Linksys ones, there was stuff that you could enable, and it would actually put out almost a watt at Wi-Fi frequency. That's pretty crazy. So it made a nice little access point when you were on the go. You just stay connected to that, and it automatically did everything.
Well, why is it not like that?
But I wanted to take one of these and stick it right to the side of the router. And I never got around to doing it because they didn't need to do it, I guess.
For a second.
Yeah, I think I got it off an RC site. The more I think about it, so because it's ICR. This is what's on the package. No, I don't know if I got those on Banggood. No, it was an RC. That's right too. I think it was an RC site.
Oh, did I tell you about? Yeah, I did. I told you about the drone camera and the motors I got. I don't know what I'm gonna do with them yet, but the drone camera is what I really wanted because it's a special low light camera. So it's a star camera, so you could look at the stars with it. It's sensitive to IR.
Huh.
That's the reason I wanted it, and I bought it with the boosted transmitter, so it's like 3 kilometers, I think. And I'm gonna talk to H or Hector and see what kind of stuff we can do to it.
Yeah.
Make it go a little further, and maybe with a little less interference ability.
Gotta get cracking on that.
Oh, your core, yeah. Oh, yeah, you need to try to make a meg because that's what it looks like you're doing.
Yeah.
Yeah.
It will be.
Those magnets are probably too strong for that.
Actually, they're not. They really aren't.
You don't think so?
No, because think about it. Everything is split up in half.
Yeah. You sure you're not oversaturating it?
No, I'm not. Because if I was oversaturated, I would not be able to take one of these magnets and flip the polarity on the ring. You know what I mean? I would have to be like a lot of magnets, or maybe even something this big, to get on there to flip.
I see what you're saying.
As a gauge for saturation, I've always tried to find out how low. It's like if what I'm going to probably do is I have some aluminum that I had cut up the same dimension, and I'm probably going to put a piece of aluminum square on each side of that.
To slow it down?
Just to slow it down a little more, and do both magnets. I want to keep everything even, and then see if I could take less magnet than that to flip the polarity. You know what I mean?
Yeah. You know what's funny, Tim? You just made me think is that a lot of people watching this right now, we're talking about stuff that typically in electrical engineering they tell you is no good, like reactive power, what Tim was just talking about. Those are things normally that you try to avoid in electrical engineering. So it's kind of funny how when you start playing with it, it actually you can get some interesting effects. Like I remember, I don't know how much you want to talk about it, but remember your very first Meg, Tim, in the wax.
Yes. Yeah.
Remember, well, I just wanted to say about how you went about building it. Was that you just decided one day, I'm going to do stuff that makes no fucking sense until something happens, and that's what happened.
Yeah, exactly, because everything I was doing, I was coming close, but still no cigar. And that's like, and then carefully analyzing everything I do to be completely in tune on what's going on, and realizing that it's like, all right, so I'm going to start doing the opposite of what I think I should be doing. So nothing extreme, just the opposite, and the rationale of thinking what's standard in the industry, what's normal practice, what's normally accepted these days, or has been accepted. There's only, everybody's been programmed to do things in a certain way because that's the only way that it'll work, when really it's not. It's the illusion of thinking that's the only way it's going to work, but it's the hardest way to go about it, but it works, but it makes people money. So, and in this, so north and south are pointing up this way and that way, and the same on this one. So to take the flux from this half from here and push it over here, which is going to take what's here now statically and push that way. So all you're doing is you're blocking that.
Yes.
With one polarity. Yes. And
yes, that's the trick. See, people think saturation's bad. People think eddy currents is bad. It is bad in certain things, transformers, but for what we're trying to do and put aluminum on there, guess what? Guess what that does to the field? It slows it down in time.
Yep.
Because now, just like when you try to drop a magnet near an aluminum block, it slows it down. Because then it's doing the same thing. So you can do a lot with that. I won't say too much more, but you can do a lot with that. You can also do a lot. I was going to say this too, Tim. If that didn't work, say it was a little bit oversaturated, even if it was not fully saturated, you could always put spacers in there. You could put plastic air gap spacers, or you could put in steel spacers that would conduct, a little bit of the field, but not,
aluminum.
You can adjust that. Let's just say that.
Yes, exactly. Because aluminum, I've got enough 1-inch square shims to do 2 or 3 stacks on either side of each magnet. So, and then I've got some copper. If I had to go that route, I would put some copper in there, maybe on.
Copper,
But it's got to be on both sides. You can't make it unbalanced or uneven. So whatever you do on this side, going to be done on that one, on the same, on that magnet down there.
And Tim, let me tell you something, and the viewers something else. Another material you might try is lead or bismuth. There's a lot of materials actually. If you do your homework, but bismuth is a very good magnetic field blocker. But it's not magnetic. So
right.
It won't interfere that much with the magnetic field, even though you can make Hall sensors with it, it's still not going to interact with it the same way. But it loves to block it. It loves to block it. So what you can do, and then I said in the comments about shaping fields with iron, you can use iron, or you can use other stuff too, because what Tim Johnson was saying is a blocking technique. You're using the Neos. I don't know the full story on that disc, but it sounds like he's blocking. Either blocking flux and allowing the permanent magnet flux to flow through the coil and then interrupting it. You can do the same thing with bismuth. You can pour it really thin. I just poured some today. I was on the phone with Tim earlier before we went live, and I was pouring. I'm trying to make that cast, and it messed up. So I had to start over. But you can pour your own bismuth real thin and make sheets with it. And if you alloy lead slight amounts, you can go all the way up to about 40, I think it's 42% makes a good alloy. so that it makes it less brittle. But you can make a good shield with it. You can shield radiation. You can shield magnetic fields. So something to think about.
Mm-hmm.
You know, even if you're blocking half, say you got a sheet of bismuth with a hole in it, or you put, you know, a real thin slice or a big slice or, you know, half a slice. You could do a lot of different stuff.
Well, with what's nice about the aluminum squares is,
Yeah.
and in the copper squares is I've got some of them. I've got holes drilled in them.
Yeah.
You know, like
Yeah.
half inch holes, just drilled right in
so
them.
You're just a little bit.
Just a little. Yeah.
Yeah. I bet the people listening probably got their minds blown just now, like how in depth.
I don't know. Do we even have anybody listening?
Some of this, yeah. There's a lot of tricks, man, and we're not even talking about probably 80% of them because it's a lot. And you wouldn't understand it anyway. They wouldn't get it. Most of them wouldn't get it because they wouldn't know what the fuck we're talking about. So, for the most part, because we have like almost a different language too. Than most electrical engineers.
Right.
Because certain terminologies were altered. And then they got taught in college all this stuff. So what that does is it actually blocks them from being able to be creative because their brain will never venture out because they think that there's nothing outside the fence. So they never cross the fence. They never decide, I want to jump the fence today and see what's on the other side. They told me nothing's over there, but I can actually cross it if I effing want to. But they decide not to because they're told so many times it's not worth it that they shouldn't, and they get offended by talking about it. And it's kind of crazy. It's like, why don't you just go up the fence? Why don't you go check it out? Why don't you try some of the stuff that's written, you know, that actually is like big name people like Hector and then you, and then because you had a lot of writing too. I think a lot of it got deleted though. You've got a feud over there, but I don't know. Even on your YouTube for a long time, you had some really risky stuff up in my opinion. It's like, oh my god, I can't believe it. I can't believe this guy's got this up here.
What's that?
Remember the 8-watt that you had up for like a year or two?
Yeah.
The whole video, the whole thing. It was like, I can't remember how. It was over 10 minutes. It was like close to 15 minutes long.
Yeah, I left it up for a while. I gave well, they wanted anybody that's doing that, I figured if they give somebody a chance to run into it and maybe download it before I shorten it up. Yeah.
The thing was, all your videos were named for you, like named in your organized way, so none of the titles really made that much sense. It was like part 913 or something like that.
Yeah.
FreeJet.
Yeah.
And you had to actually go through each video to find them. If you wouldn't have done that, you would have never seen it. And I remember when I found it, it was only like 400 views or so. And a lot of people may not even realize what they were looking at, but until you started saying what you were doing and explaining it, I remember you took stuff off, put stuff in, and how the machine responded and all that. I won't get into specifics, but yeah, you remember that.
Yeah, I had one guy wanted to pay me. He wanted to pay me like $23,000 or $24,000 for the 8-watt machine.
Yeah, and that's not even the best way to do that, right? We know what the best way is, but you only went that route this time because you were hoping to get more power out because technology has gone with the EDLC technology, the driver technology. I mean, who wouldn't? Why wouldn't? Because you would think you would get more, but it's actually looking like the older methods were the better ones.
Yeah.
You know what I mean?
Yeah.
You know
you know what? It was just before
first gen.
It was just before COVID.
Yeah.
Because I remember that guy. I think COVID killed this guy because I thought for sure it was black plastic clock box, and he wanted it. I don't think he even realized it was looped. He just like, I want that thing. And the email was like,
he knew.
Yeah.
He knew if he was offering 24K, he knew it was.
Yeah. So, and I was like, I'll think about it. I wanted way more than that. You know what I mean? And so then, but when they made the other one that was in clear plastic, and I was like, where the hell is this guy now? Well, it's after COVID,
Right.
so I think COVID killed him. Yeah, unfortunately.
Yeah.
Never heard from him again.
Yeah, that sucks.
Yeah, COVID killed
But
so many people. Ridiculous.
you got to remember, guys, though, that even 8 watts, that's equal to about 24 watts if you had a solar panel. Maybe even more than that, because with a good solar panel, you're lucky if you get 6 to 8 hours of good sunlight a day.
Yeah.
And your efficiency's not, it's all day. On the panels, already shit efficiency. So you're really not, if you have a 300 watt panel system, you're going to be lucky to pull 250 average, because just the sun's up, there's a cloud, and then it starts to go down. Your panel, unless your panels move, then. But if you have something that continues to run 24/7, you can have a lot less power, and it's still significant because it's still charging a lot. And you're talking about, like, there's a lot of possibilities, man. Even with a small one, for what you could do.
Yeah. So this is.
What do you got there?
So this is my prototype, my cloud bounce, laser cloud bounce.
What?
Yeah. So
Your what?
projection TV lens, and also I'll slide it back.
What the fuck does that do?
It's
You never told me about this.
it's a receiver. It's a receiver.
It's a prototype receiver.
Yeah. So
what's it receiving? Looks like a damn quantum computer. What are you pulling out of there?
So there is another card in here that has the laser receiver. I'm gonna have to put some light in here so you can see.
Oh, is that the?
So you see this sliding up and down?
Oh, okay.
So that's the focus.
Not real well.
All right, let me dim this thing down a little. My wife's probably watching 4K movie or something.
I can't tell. Yeah, no, it's loading. It's saying it's loading.
Huh.
Yeah, I think it stopped.
Ooh.
Yeah, I don't see nothing on your screen anymore.
I still say I'm still live. It's on my end. It says live.
Maybe it's my internet then. I turned the quality down. But it's still doing the spinny thing. I don't see anything. Now I see you. Yeah, maybe it was mine. Maybe I have weird internet sometimes.
So anyway, see this? I've got this all set up with
yes.
So I got a potentiometer here, so I know the position of this slide plate from this end to the other end. The photodiode, the pin diode, is in the receiver, and the buff amp is all inside of that card that slides up and down. And that centers out on the focus point of the projection lens, an old projection TV. And then this here, all this stuff is just there is a transmitter in here that transmits on the VHF band for wireless audio, and also let's see, 1, 2. I think the gain. I'm probably right around 70 or 80,000 to 1 gain with this. But what I was doing with this was I was doing cloud bounce. So initially I was doing 432 nanometers with me and this other guy, this other gentleman in Marshfield, Massachusetts, and we would shoot up at nighttime on a winter night. Would probably be like maybe 80 or 100,000 feet up. There was in the wintertime up in the Northeast, you got this ice crystal layer up there that's, it's a real nice mirror. So I could project a beam up there and collimate it so that the point um, was at maximum audio level for his end because it was a loop system. So we had full duplex communication once we connected up in the atmosphere, and we were running computer data. So once we got linked up, we could actually type or do audio back and forth through the computer.
Hold
And
up. What were you aiming it at?
cloud bounce. We were bouncing it off a layer up there.
Oh, a cloud.
Not a cloud. Well, we were doing cloud bounce. That was the interesting because it had an airy sound to it. But if it was a clear night, we'd be in the I forget what layer they call it, but it's like a lot of ice crystals, high altitude, and it acts like a really great mirror. So the person that I was communicating with was 18 miles away, and so we're pointing our lasers up to the same spot. We connect, we link up, and then now the computers are talking. Um, Once we set them up in the tripod, you could go back inside because I was linked up through radio on this, transmit and receive, and I can control this from the other end because I was hooked up to the computer with our data modem. So it was kind of interesting. We could do sounds. We could send. I sent a video to him one time. He sent one back to me.
No shit. You were
Yeah.
able to modulate all that.
Yeah. Yeah.
Or just make it, use the normal modulation that's already existing. You just put it in that.
Yeah. No, we did a legitimate computer link up. Yeah.
I see. That's pretty crazy.
Yeah.
So did it shoot? What did it shoot? Did it shoot a laser or a light?
Well, the laser mounted on top of that. That was that's the receiver.
What size laser did you use?
I was using. This is gonna blow you away when I tell you what I used. 3 milliwatt. 3 milliwatt 432.
Whoa. That's it?
That's it. Yep. From there, we went up and we did infrared. So we were doing 8. Oh, I don't know, like 860 nanometers, somewhere in there. And then we ended up taking. We ended up getting a part number for infrared. I think ultimately, before we got bored with and stopped, I think we were doing. I think it was 1 watt 980. I want to say 980 nanometers.
Okay.
And that was, I think, just about a watt, or almost a watt. And
was
it was
it a gas tube or solid state?
It was solid state. Yeah.
Oh yeah. Okay.
Yeah. But I mean, it was too loud, overdriving. It was, it's like if you were on the moon, it'd be perfect, but that kind of power was just too close. We had all kinds of problems. The 4 or 5 milliwatt, 3, 4, or 5 milliwatt was the perfect range because it was no overpowering and no data loss. Yeah, we thought stronger was going to be better, and it was actually worse. It was the other way. Yeah, but we got bored doing that. So then we started looking at the moon, tracking the moon, and listening to what's coming back. So when you take one of these receivers and start digging away at it at the audio spectrum level, there is literally rumbling. So We think we were hearing the solar wind. We're still not sure. But the sound, it sounded like it was like
Huh.
that type of noise, and it
Like
would
a
sound.
screeching wind noise.
Yeah, but it wasn't. You know, it was a solar wind. So we're listening to reflected light on the moon at nighttime coming from the sun, and that's what we heard. Yep.
Wow.
Yeah.
Yeah,
Yeah.
that makes sense. If you can see the moon, then you're seeing sunlight.
hmm And then the other thing that I found interesting was I would go up. When I lived up north, where my house was on top of this hill, and we were 200 and the whole development was up there. But we were like 200 and something feet, like 240 feet above sea level, from where the downtown area is. And so, anyways, I got up on the roof one night, and it was like it was just about almost going to rain, and I wanted to catch raindrops. I wanted to catch the storm further away, and the only way I could do that is to clear the top of the tree lines was to go up on the roof. So I went up there with the 432 3 milliwatt laser, and that receiver that I just showed you. And so I'm on top, set up on the tripod. I'm swinging around, and I'm constantly doing a 360 very slowly. And all of a sudden, I hear it, and it's like, "Bop, bop, 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 bop." And it was like I stop right there. So I'm pointing off in a direction, and my laser beam is underneath the cloud layer, where the rain is dropping. And so as the raindrops are falling through my laser beam, they're lighting up, and I'm getting the signal back. And this was like, I don't know, miles away, very far away. Yeah, but that was,
Wow.
but that the water when the drops were dropping through, if it hit the beam, they would light up, and I would hear it. It sounded weird. Yeah, interesting.
So, well, you were just modulating with a PWM into the laser, right?
Yeah.
The diode?
Yeah.
And then you're just using a photo to pick it up. Okay.
Yeah, we used to come right out of the R232 port and go right into it.
I wonder if
And we-
I wonder if they can handle the gigahertz range.
Well, we did a data test, and we were probably
5 gigahertz?
well, we were better than dial-up. I know that at the time, because it was like I remember Dave going like, "Holy shit! Yeah, we should start our own internet ISP."
I'm pretty sure you can with a laser. I'm pretty sure you can go higher than that.
Oh, it was up there. The data rate was let me tell you, put it this way: we could send a sound stream and from him to me, and it would be real time coming in. It would sound normal. You know?
At the speed of light.
Yeah.
That's wicked, man.
Mm-hmm.
That's wicked, but that would be a really noisy communication method. It would be a good emergency one, maybe.
It's a little it's a little crazy to try and line up. You've got two people that are 18 miles away. He went up a water tower one night. It was a fire lookout tower. He went up one of those, and that was the best one because that was on a hill. And I set up on the roof of my house to look over the top of the trees, looking down at him. And we established a real shitty line of sight connection, but we pulled it off. And I had no idea what was in the way between me and him because he's 18 miles away. But somehow it worked, and I could hear, and he could hear me. Yeah.
See, that's what I was curious how I could if I could somehow wire in a transceiver to a laser on a remote. That's what I want to know.
Right.
I think I could. I'm gonna try. I might get like a cheap helicopter I love those too, man. Those remote control hooks. They're the funnest damn things, man.
Yeah, Mr.
I used to
Johnson.
run mine so high until it would run out of range and then it would just fucking crash. I remember, and it wouldn't turn back on either. It was weird. It had to crash before it would start working again.
Yeah.
But it was fun though, man. That thing was wicked fast. It was crazy how fast it could fly. I might try it with one of those if I could keep it aimed at it. But I would just try to hover far away and see if I can control it with it. And you could even use a light, probably like an LED, so it's a wider signal.
Maybe.
You know what I mean?
Yep.
You can buy a IR LED and then fire it into that, and then the drone could pick it up from. There's no telling how far. It'd be like a giant remote control to a TV. That's what it would kind of be like.
Yeah. It'd be kind of funny.
And if you could find 964 nanometer, it'd be pretty much completely invisible. But of course, the drone sensor would see it. So you could literally have a spotlight on a tower, at least driving one drone. I think it would be probably just one. You could probably do more later, but yeah, it'd be like a light antenna.
Mm-hmm.
I wonder how many people's thought about that. It would be omnidirectional too, so you could fly it around, and you would have free range because it's omnidirectional. You just make the transmitter omnidirectional.
Right.
And you know what else? That would be unjammable. The only way you could jam it is destroy the transmitter or the drone.
Right.
Because you can't block it. How are you going to get something between it physical? Can't. So you would have to destroy the transmitter, and you'd have to see it, which you could with a camera, with the right, even night vision, you could probably see it. So it would probably show up huge on a IR camera, so they could probably shoot it down. But they'd have to hit it, you know what I mean? And what if it was in a window or in something like that? This is just like a random scenario, but it would be interesting because it would have a military purpose. Like they could use that on the battlefield. You know what I mean?
Yeah.
Because imagine the range on that. Like how you have a 200 watt LED IR. How far do you think the drone can see it with a very sensitive, a couple of photosensitive sensors on it? Just food for thought. All those drones up there. That would be one way you could make an unjammable signal. And all you need is a beacon up in the air, and no one's looking for it.
Talking about the ones in New Jersey? You think they're talking about the ones in New Jersey?
Yeah, no, I don't. Those are AI driven, probably. They're just on missions. Like you could send those out on missions, and there would be nothing you could do to jam it because it's all self-contained and EMI shielded. So
yeah, Thomas.
Unless you hit it with a major EMP weapon, it's not coming down.
Right.
You have to hit it with either a nuclear charge or a very big capacitive charge to hit that. To be able to bust through or at least charge it so much that it just destroys from the electric field. But that would be it. You could do a nuclear charge and it would do it.
Mm-hmm.
What do you got now, Tim? What are we telling them now?
Yeah, well, this is my giant jewel ringer that I haven't done anything with.
Hey, save this so I can put it on my channel too.
Yeah, it is. It's been. I think
Good, man. You didn't even tell me about all this stuff. You have so much shit, man. You have like shelves of shit. This goes back 40 years.
Yeah, pretty much.
So it'd be impossible for you to show me all of it. Probably.
Right.
I don't think you could. It'd have to be a full-time job.
I had a lot of stuff. Let me put it this way. I had one of my 2,000 square foot bays that I had, about 400 square feet of it was a storage area just for some of my shit. Then I had a lab in there, in one of my shops. I had a lab at home. Yeah, so I mean, it didn't matter if I was home or if I was there. I had projects in both places. I would come back after doing a job like 2:00 in the morning and stay in there till 4 or 5 and work on a project.
Yeah.
So,
Man, I can't wait till we get a house. We're gonna get one next year, probably in the spring, and it's gonna have a garage. And I done told her it's either gonna be detached or I'm gonna have a 3-car.
yeah.
Oh, when we're off the air, I'll tell you something later that Steph's probably about to get into that might be pretty significant. So
Oh,
I'll tell you
good.
about it later. Yeah. Yeah, she had like a 2-hour phone call today with somebody that's like the VP. I can't remember what he does. It's some kind of healthcare thing. So yeah, there might be something happening pretty soon. Yeah, something kind of crazy. I'll tell you about it, man. It could be a lot.
Yeah.
She could be
Keep it off here.
significantly raising.
Yeah. Hey, give me one second.
What about this ringer? Tell me about this ringer. What, you got a core in there?
Yeah. You want to see the core?
Yeah. What you got going on there?
So this one I'm gonna fire off soon, hopefully. Give me one second.
Damn, that's pretty. You just hand wind that?
Yeah.
I think you told me about these actually.
Yeah, this was.
You told me about them a few times. Yeah.
Yeah. So this one. This was, this wide, but I cut it in half with a tile saw, and then glued them together.
We can't see it.
Can't see it.
Where your hands? Yeah, I can't see your hands right now at all.
Huh. Get some more light on this then.
No. You're out of the view of the camera.
Oh.
Yeah, you're back too far or something. I
Okay.
can barely see your fingers now. See the blue thing on the tape? That's where you need to be. There you go, right there.
Yeah. Okay, so ferrite core. This was longer until I dropped it on.
Actually, I think that's why it's messed up.
Yeah. I dropped it on the floor, and that was long in there.
Yeah, the bar. Yes. You told me about that. That solid bar.
Yeah, incredible loopstick antenna for an AM radio. Holy moly! Yeah, wow. I've got another one that's I don't have it. It's not accessible right now, but I've got another one of these.
That's a K-rod container. Right?
Yeah. Yes.
Yeah.
Perfect. I've got another one with different windings on this end and this end. And it's basically, I can tune that for the whole HF bands and down into the AM radio and then below. Yeah, but I've transmitted on it. And that's amazing. Yeah.
Really?
Because all you got to do is just.
That right there with no antenna?
This is the antenna.
Oh, okay.
Yeah. Yep.
I thought maybe you hooked something off to it, like something else. Like maybe that was like what you were resonating and then sending it off.
Yeah, so I mean that's the core. I want to do another one that's going to be all welding rod in there. See how that works out. But, yeah, so this is the collection coil, and that one there is the one we're gonna drive.
Okay, so you got two under it.
Yeah.
Is that right?
Yep, and then they're gonna
see the one under it.
Put one more coil on top of this, wound the other way. Yep.
Are you trying to make a vibrator? What Gary called the vibrator?
No, the jewel ringer.
Okay.
Yeah. Jewel ringer. Yep. But the output coil is wound in the opposite direction. Jewel ringer, I think it's bifilar. They're all wound in one way. It seems like there's more to get when you're.
Yeah, I think you're right.
When you configured the other way, because now you're You're
Yes.
only looking at the back EMF after
Yes,
being
and that's how the little Russian ringer works.
right.
Yes, it's a jewel thief that's a modified variant. It's
Yes.
got a backwards coil on it, and that's what's driving the LED, which is also switching, and it can switch fast. The LED can. So that's why. And it's weird because it lights up and it's just open. There's no resistor or anything. So. Oh, I wanted to say this too. Hector was telling me that LEDs. So if you take 4 LEDs, say you take 6-volt LEDs and put it. I can't remember. Maybe it was 12-volt LEDs, and you put them all in series for 48 volts with no driver, no resistor, and you hook it up. He says it won't blow. It'll work. He told me to try it. I haven't tried it yet.
Yeah, because you get a voltage drop. You have a voltage drop for every LED, so you just match that to match your voltage.
Right.
And you won't be overcurrent. Yeah.
Yeah. And so what I was getting at was, so he showed me a picture of a shop, I guess, where he lives, and he's got a few LED fluorescent replacement bulbs. They're LED though, you know what I mean? But they're in the housing. That was running off I think he said a 50-watt solar panel on the roof. So during the day, I think he had a battery or something going too. But during the day, dude, that thing was freaking lit up. Like, it was bright. So in the daytime, he had a free light in that room. You know what I mean?
Yep.
And he had no driver. It was hooked straight to the panel. And he said it's been like that for years. He just runs it and gets a free light during the day. And he, of course, Hector's got other stuff probably that's going. So to help him out. But the light was interesting. I thought that was really cool, because if you had like a dark room or like a shed or a barn that was dark and you need to get in there during the day or in the morning, and you had morning light, that would be great to have morning light already on.
Yep.
You know what I mean?
Yep.
The moment the sun hit that panel, it's going to start to come on, and then you got light when you go in the barn in the morning. So it's really a cool setup, because it's like leave it and forget it, because there's no battery, there's no driver, there's nothing. It's straight up diode and panel. It's kind of ingenious. That's why I like Hector, because he's always got these crazy little ideas that'll blow you away, man. It's like, dang. And so do you.
Yeah.
Golly, I don't know how y'all come up with all that. And then I got ideas too. Mine are different. You have to think simple. If you think really simple, you'll be surprised what you find out, man. If you think just super simple stuff.
Yes, if you keep it simple from the start, you're way ahead of the game, because the minute you're trying to overcomplicate something that doesn't need it, it's like you already fucked yourself. You might as well just give up and go home.
And I want to say something too, because me and Tim were talking earlier about the boards we're going to make, and we're probably going to make a few different things. That one of them will be just kind of for fun. It'll be the UFO detector, but which we think will work. We wish we had it built a couple weeks ago, because I had drones right over my house. It would have been great to have that, because I could have got a damn sure good test.
Mm-hmm.
That, because we're sure that's what it is, but we could at least tell if the drone is using a certain technology. So that's why we want to do it. So we'll probably do something like that, make it real sensitive, because Tim knows a bunch of tricks how to make stuff sensitive, so we could do that. And then, so if you're trying to build something like what we do, if you look at Tim's videos and my videos, you have to think about matching your parts up. Like, you can't just go grab whatever you got. I mean, you can, but you can't have high expectations, because you have to put a little engineering into it. And you just have to really put effort, and then you'll be surprised the progress you make, like by changing the bearings, emptying the grease and putting oil in it, or getting ceramics. Kind of pain in the butt. But because once it gets a speck of dirt in there, it's done. But I like Tim's idea, where you just fill them with sewing machine oil, drill a hole in the side, make it at the top, and get the bearing. The plastic doesn't turn, so it just stays there as a cover, and you fill it up with oil, and it doesn't really leak. It might leak over time, but you just fill it up. As long as you don't smoke it. Even if you do, you could have a new bearing. So what? Have a couple bearings on hand, have a couple belts, have or a chain. Chain as a backup's a good idea because the chain will last you a long time, even if you run out of belts.
Yeah.
So, yeah, that's why I got on the generator that I'm making for YouTube and everybody. I'm going with the 41 chain because it's a light chain, but it's still heavy enough that it can handle all the torque. I didn't want to do 35 because not with a diesel engine. I didn't think that was a good idea, Tim. You know what I mean?
Yeah.
So I went with the 41. 41 should hold it. So it's only 3 horse, but I figured it'd probably snap that thing for a while. I put a heavy load on it, and it'd probably snap it. Especially if it was an inductive load, something that hit that generator real hard, it would probably snap it. I don't know. It might hold it. I can't remember what it's rated for, like 1,100 pounds. That diesel's got a little torque, man. It's a little torque monster, so I don't know. And it's hammering away. It might be able to break it.
The compression release, is the hole big enough?
On the motor?
Yeah. Does it have a choke hole?
It's the timing. It's not that. Yes, that's good. I think I could make it bigger, but it feels good. You got to get the hang of it, though, and that thing's got to be bolted down. You cannot start it without it fucking screwed down or bolted down. Get some 3-inch wood screws, screw it to a pallet. Actually, screw it to 2x4s, and then screw the 2x4s to the pallet with lags because, man, you will. And that little red motor is so light. It's only 44 pounds, so a grown man can pick it straight up and walk with it, no problem. And I'll probably freak my neighbor out because he's seen me do it. But it's not that heavy. So, yeah. And when you pull the string and the compression kicks in, that motor is coming with the string in your hand. You will lift that motor off the ground. So, and if it starts, you're in trouble because now it's on its side, and all the oil's not where it's supposed to be, or it's in the dirt with the shaft fucking beating away. So yeah, you don't want to do what I did. And I didn't tip it over. I grabbed it real quick. So, and I killed it. And then I strapped it down to the pallet with a couple straps, which didn't work either. It's trying to vibrate out of those. So, but yeah, get bolted down, and then it starts pretty good though. Once you get the feel for it, it starts easy. Yeah, it fires right up. Once it's primed, you got to prime it by hand,
right,
with the hose. Yeah, once you fill the pump up, make sure all the bubbles are out. And then while the hose is kind of running some diesel on the ground, stick the hose back on, put the clamp on it because it'll pressurize and blow off. If you don't, I learned. I got a gallon of diesel in my back seat of my car. And now I gotta buy a whole new back seat, dude. I'm gonna go to a junkyard maybe next week or so, and I'm just gonna buy a whole bottom piece. I'll see if I can get away with that after I clean it out, and then I'm just gonna throw it in the dumpster and then put a new one in, and then see if I got to do the back seat too.
Yeah, it's a shame because it takes.
If I do, whatever. I'll do it. I'll fucking replace the seat, dude.
It sucks as the floor liner. You're gonna have to change the floor liner on behind there, and because.
No, I think it went into the seat's bucket. There's a little bucket in that seat.
Oh.
It's hard. You'd have to see it. I don't think the diesel got into the floor. I think it went straight through the seat.
Good.
And soaked into that seat. It was a little less than a gallon.
Yeah.
It was 0.7 gallon. And it was all gone too. It's empty. I was like, shit. And I didn't even think about it. I should have put the clamp on it. But yeah, I gotta get a new seat. I ain't even gonna mess with it, man. I'm gonna try to clean it. I'm gonna get a new seat from the junkyard. Because that seat was already kind of rough because I treat that car like a truck. It's identified as a truck since I bought it. So I've got a whole mule truck in the trunk. I got the tires, wheels, axles, everything. Everything except the frame and the motor is in the trunk of the car right now. And it's full too, man. That poor thing looks like I put a lowering kit on it. But I didn't. It's probably got about 600 pounds in the trunk. I gotta take it to my land. I might take it tomorrow and drop it off, get it out. I got that frame in the back seat too.
Do you?
I think, yeah, but I'm not done with it. I gotta finish it and then I'll take it to the land because I might have to take it back into work. But I don't think I will because I'm gonna make the aluminum frame bolt down to the metal. I'll just tap it home, drill and tap some maybe some 1/4-inch bolts, into the frame and then screw the aluminum to that through a tab, just like an L bracket, and then put the covering on it. And the frame will accommodate the fuel tank I'll build for it. I'll build probably a 5 or 6 gallon fuel cell out of aluminum, because it doesn't. That's not very big either. You'd be surprised how much fuel you could fit in a 7-inch deep. I say I'm going the full width, so it's going to be like 17 inches wide, 7 inches deep, and then it's going to slope down to kind of like a ramp.
Yes.
That way it always drains.
Always going to get it all. Yeah.
Yeah. And I'll make it to where there's always I'll either put a screen in there like copper mesh, or just raise the pipe a little bit.
But listen, it's a diesel, so what you want to do is get a boss fit and weld that in there so you can put a drain in that thing so that you can drain water out for condensation.
That's actually a good idea. Yeah, you're right. I need to get a water separator for it.
Yes.
And a filter. It's got a filter, but you're right. I need to try to find a miniature water separator. That's a great idea. I didn't even think about that, Tim.
Yeah.
God, I love having you around.
Well, I mean, the diesel.
There's got to be a mini one.
It don't like water, and it's a problem.
No, you're right. I didn't even think about. Even though it's mechanical, it's still probably popping off. What do you think it's popping? 2-3K?
Oh, easy, yeah. And you know what?
Yeah,
I guarantee you ruin the injector. You get enough water in that injector, forget it.
It'll break. Yeah. Yeah, I know. I broke them on my truck. That's how come I had to tear the head off. And then it busted a ring, so I got to deal with that. I got to do an in-frame on it because I think it's within spec, and the bores weren't bad. So I think I can get away with it.
Yeah.
I think I can get away with it. Yeah, I'll redo the bearings, the rod bearings, and the rings, and I'll hone it. I already looked, because I can do it pretty cheap as long as I don't need to get a piston, and I don't think I do, because when I cleaned it, the pistons looked great. I just couldn't see number 1 ring, and I didn't do a compression test because everyone, when I was at school, they were like, "Fuck compression! All you got to do is listen to it." I'm like, "Whatever."
Yeah, right.
I wanted to do it. I should have done it, but that way I would have known.
Compression test is that's a real.
Because I could have seen it. I could have seen it on the damn gauge.
Yeah, our compression test is that's a real number as a reference. Going by air is insane.
But they were like, "No, you can spray air into it and you can remove the lid." I was like, "Yeah, that's like a leak down." But that's what they do, and they've been doing it 20 years. But they work on the big diesels towards just run it. They just run it anyway. It's like, okay, I don't want to do that because then it's going to tear the fucking engine up.
Mm-hmm.
And then I really got to take it to a machine shop and have it decked and bored, and then they tell me the engine's compromised because that Cummins block's it was never designed to be bored out. So when you bore it out, it's actually thinning at the water jacket. So if you try to make a racing truck out of it, you'll break it eventually. You'll break the block. So, but if you're making like a daily driver, you're probably okay, which is what I would do. I would do 20 over if I could, or 10 over. I think you got to go 20 over, which I think 20 over is fairly safe. But you go 40 over, you're risking something, especially if you're pushing power like 600-800 horse. You're risking it,
mm-hmm.
especially if you're froggy on that. Like if it's a 6-speed and you frog on it, yeah. I used to have one, so I know what it'll do. Especially if you got a straight axle. I mean, a straight drive line.
Yeah.
You get an aluminum straight drive line, that motherfucker will damn near pop a willy. You have concrete in the bed, might pop a willy on you if it's a dually. Because I tell you what, my truck, that fucker was fast, man. It was like it would run like a 13.9 quarter mile, I think, when it was in its normal state without the welding bed. Now it's slow as fuck, but it's a waste of like 9,500. So its gas mode sucks too now. Oh, what's that?
So I got the idea for apologize for coughing. So I got the idea for this when I was doing this.
Okay.
So this is, I just made like poor man's lits out of.
Yeah. What gauge is that you made that that up?
I think it's 30 gauge. Yeah, I think it's 30, and there's 15. I think I put 15 in here.
Damn, that's fine. Are you sure that's 30?
Yeah.
It looks finer than that. Maybe it is 30. I've got some 26. It is pretty fine. So
Yeah,
yeah,
there's-
I guess it probably is 30.
Let's see if I can dig one out.
You got some of that. Man, Gary had a bunch of E6 wire in that shed. Or that thing, I think.
Did he?
You remember?
Yeah.
I think he did. I think he did. I think he had a few spools of it. That's like $100 a spool, man.
Well, he was getting his magnet wire from a motor rewind guy. It was like, yeah, every kind of wire possible.
Yeah, I think because they were E6 rolls. Either that or it was you that had a bunch of E6. I have a bunch of them too. I have 5 or 6 rolls.
So
different size wire.
pulse on this.
Okay, tell me about it.
I had this configured like this, like the big boy, and I used. Actually, I can't even show you. That's a shame. I can't do that. I'll have to send you a private video because I got something.
You had some little magnets?
I got some.
String. Oh, there it is.
No, I've got some magnets over there hanging on an angle. It's hard to describe. I'll do a video on it and let you see it. It's going to blow you away because as soon as I put the key stock on the end, I'll show you. I've got all these magnets hanging in my shelf from the top, and it's on an angle like this.
Yeah.
And the big magnet, the big magnet I just got, the big 1 inch thick, what is it, 3x4 magnet? It's pointing towards that, but on an angle. And if I move the magnet just a little bit more out of reach from the distance, it's kind of does this. And when it does that, it starts moving. It's weird. And I think what's going on is the flux. I think it's catching the flux lines, the flux of the earth. Whatever disruptment's going on with that particular flux line that happens to be going by me where I'm standing will wobble this. So this stays on an angle. So when I go in the garage, the first thing I do when they turn the light on, I look at this to see if it's moving, and it's always fucking moving. I'll show you. It's kind of neat. But I had some of these magnets. I think it was 3.
That's a ceramic, right?
These are no, these are Neos.
No, the one on the table.
Yes. No, this is just ferrite.
Oh, okay.
Yeah, but the other magnet, this magnet, I'll show you.
Yeah, that one. Damn, you got a lot of Neos, man. Where'd you get all those? Amazon?
Yeah.
Did you get those from Amazon? Man,
Sure.
Those probably not very good. Maybe they are good. I don't know. I got some and they suck.
Yeah, they do. So the thing is doing this. I'm holding the thing so that you can see the angle. But see how this
Holy
is.
Shit. Yeah, be careful.
See how this is.
Son of a bitch.
See how this is doing that. So when I move this away until this just starts to drop.
So you're almost breaking the flux. That string is
right there. Yeah. So anyway,
it's just barely hanging on. There it is. Yep.
So it will hang like that in the shelf, stuck to the metal shelf, and this is stuck to the bottom, and this is on an angle like that. And every time I turn the light on, they go in the garage. This is always doing this, just
almost like a poltergeist.
Yeah, little. So anyway, those magnets. Shit. Those magnets.
Yeah, because they're on the clock box.
Yes.
They were doing that, aren't they?
Yeah.
That's how you first found out.
Yeah, exactly.
Yeah, it was on the clock box, and you're like, "Damn, these keep moving."
So, anyways,
yeah, these keep moving.
I had 3 of these on each side of here, right? Put this over here. Yeah, so bottom line is I was like this. So just like the big boy. But the interesting thing is I get more out when I pulse this side and I take my power out of the multifiler. If I pulse this, I get less out of the single conductor. So this.
Hold up. Now, is Does it change when you flip the polarity of the magnets?
No, it's the same outcome.
No.
Yeah.
Okay.
So, Litz wire, I think any form of Litz wire for whatever you're going for current is that's there's so much surface area there, and they're not connected until the end.
The skin effect
Yeah.
is less.
Yep.
Yeah. Because there's more copper that's isolated to give it a skin effect, so you're essentially able to collect all that high frequency ringing that you're creating when you pulse that, because those magnets love to ring at high frequency.
Yep.
Yeah, especially in ferrite. And do you think that Akula's ferrite deteriorated because of the effect he was to ferroresonance, or do you think ferrite was just old? What do you think, Tim?
You know something?
I almost think it was a material effect that just deteriorated.
Yes.
Almost like a decomposition, maybe.
Yeah. Have you ever
Like
taken
we were.
Flint? Have you ever taken a high frequency welder apart?
Yeah, I got a couple of them.
Yeah. Well, I mean, when you have one that don't work very well anymore, or don't stop working, the core is fucking fucked. Yeah.
Yeah, no, they do have. I got my little one has a pretty nice core in it too, but it's a toroid.
Mm-hmm.
Yeah, it's a pretty good sized choke looking thing. Yeah.
So I mean, these are ferrite cores, these guys, but that's another one I want to do. And try ferrite. Yeah, I just taped them up, getting ready for prep for wines. You know.
Yeah.
That's ferrite.
Dude, I could have made you bobbins for those. They could have snapped over them.
Oh, that would be nice.
I could have done that. All you gotta do is that. I got the printer going. I got all the shit off of it. I sent you video. Yeah. And I printed that thing that didn't work out until I got to redo it.
Oh, it didn't work?
Well, the bismuth, the main part didn't. The lid worked, but the lid's too thin. So I need more. I ordered 8 more pounds of it.
Oh.
And I got my alloy. I want to change the alloy back to 5% on the lid too of lead. So it gives it a little sheen, and then it helps the brittleness. Makes it a little tougher. Yeah, that lead adds a little bit of stiffness to it, I guess. Soft stiffness. You can actually go much higher, and it's still 50. I think it's 58% bismuth. 42 lead is a sweet alloy as well for shielding. It's like a good balance, but I wanted the non-toxic part of it,
right.
So I just went 5% lead, 95% bismuth. So when I'm touching it, it's almost virtually no lead that I'm being handled. So I can just wash my hands and not worry about it. I don't want to touch 100% lead and then wait 30 minutes and wash my hands every day or every week. I don't want to do that. It's not a good idea. Yeah, not a good idea.
This is what I want to do.
Yeah, didn't you have a viewer send you that or something?
This is going to be my Akula.
Yes. Didn't a viewer send you that core?
Yes. Yep.
Yeah, that's a nice core, man. I've seen that on Mouser. That's not cheap either. That's like $30 a half.
No, I think he told me he paid a little over $100.
Oh yeah, maybe because that's a big one. It's hard to tell the size because even the width changes the price dramatically. It can be the same size and a little narrower. Oh, I bought 2 Met Glass. I got them over here. Like, I'm not on video or nothing, but I got 2 Met Glass chokes. I don't know where I put them, but I got them from China. They're pretty good size. They're about the size of that yellow one you got, or that one with the coil on it.
Yep.
Maybe a little bigger, actually. They're a little bigger than that. And they're plastic lined, so I don't think they're taped. But yeah, I want to make a ringer with it because there's people that are doing it and getting a lot of power with Met Glass. So I want to try Met Glass over ferrite next because I can ring at 10,000 hertz, no problem. Maybe in 15, 20. If it's since they're small.
See, for me, everybody always goes for that high switch rate, and I get it. The faster you switch, the more power you're gonna get. But finding that sweet spot where you're finding yourself putting less in to get whatever you're getting out.
Right.
That's.
Well, you gotta. It's trying to think about the coil and the core. What's the core like? What frequency is your core like to be at? Then you got to think about the coil. then okay, if the coil's not there, a capacitor, you know, and then so it all has to kind of sing together. So on a ferrite, you got to ring pretty high to get it to. At least from what I understand, where ferrite wants to be, like kind of its sweet spot, sweet zone.
Mm-hmm.
But now iron, I think yes, Tim. I think we can make some serious power with iron under 400 hertz. I believe in that for sure. Maybe even ferrite too. I don't know, because the Akula, the one he had, that was a pretty powerful light.
I mean,
30 watts, 40 watts on just a motionless ringer.
Right.
That's pretty wild. That's
Yeah.
a lot of power.
Yeah.
Yeah, and then you imagine building 10 of them.
Right.
Now you're powering RV for sure. With the air conditioner, probably if you got a battery bank, you probably power air conditioner too.
Mm-hmm.
You probably do that with 5, 6. Yep. I still wish, man. I don't know how much you want to talk about the first gen, but around, I don't want to say the number. It was a lot though. The power you were getting out of that. It was just that standalone, remember?
Yeah.
Right? Was that the only thing you had going? You didn't have any other tricks going on
No.
before it went to the battery? No?
Nope.
Yeah.
Yeah.
That's
It was
incredible.
Pulsing and taken. It was Bedini style on the
Oh,
Samsung.
shit.
Yeah.
Oh, there's my sign. I made your sign.
Yeah.
I wish we could have got Gary's damn sign.
I
If his
know.
grandson got it, that's cool. If his grandson got it, I'd be happy if he hung it up in his room. But that would be real good. I need to build mine. I still got mine. I got a steel plate and an aluminum plate with my name on it, and I haven't even put it together.
Oh my God.
I cared about y'all more than that. I mean, I got it in the car. I got all the parts in the car to do it.
Yeah, you should have done yours first.
Lights.
You should have done yours first. You should have done yours first.
No, I wanted Gary's first because I was, you know, I wanted to. Oh God, look at that. The comments. Yeah.
Who was this?
Oh, I miss Gary, man.
Yeah.
Gary would have loved this. He would have been all over it.
It would have been nice to get his channel and keep it going for him, you know.
Well, as long as his son can keep it active, that way it's available.
I don't think he cares about it. He just wants to go on there and have access to go look at his videos. He doesn't even care about the channel. I had that discussion with him.
Get the password. Try to get the password from him.
I asked him, I was like, I'd like to maintain it if nobody's interested in the family to keep it going, and I wasn't getting anywhere, so I didn't push it. Yeah.
Well, you have all his videos backed up, right?
Just about.
I got some of them.
His I think maybe his last. This is the last 30 or so. I don't have. I gotta get them. I haven't done it yet.
That's me too. We need to get that.
Yeah, because worst comes to worst,
Plasma, Noble, Argon. You got someone telling you something down there, Tim.
Yeah, sometime. I mean, worst comes to we get all his videos. We'll open up another channel and redo it.
Yes, and then do a memorial for him, and then put them all back up.
Yep.
What he created a
Appreciate
plasma
you,
Noble argon gas burn. What is GG? What are you trying to say? I don't know what that dude's trying to say.
No. Watch.
Well, I do want some. I want an argon laser, man. That's the laser I don't have. or a CO2 laser. I mean, I don't know if I have the room, but I find the room when I build my shop. I'll have the room freaking then.
Who is this guy? Hey, who are you, buddy?
I don't know. He's about to get. He's blocked. Yeah. Yeah, he's blocked.
I was kind of curious to see who that was.
You can still click it. You can still click on him. You have the same access I do, but yeah, he's blocked. That guy's weird, man. I don't know what the fuck he's talking about. But anyway, let's get back to the real talk because we don't have time for that weird shit.
Yeah, he's a troll. He's got nothing but video games on his. He's from China or something.
Yeah, I block him, man. Let him keep coming. It's probably Reza. We just gotta look at it like they're Reza.
Yeah. I don't know who this is, but go to their channel. It's just like it's video games.
It's just an idiot. But anyway, yeah, I block him, man. I don't even entertain that shit. We don't have time for that crap, man. So he can go somewhere else with that. But I think they can still watch it.
Oh, I see what he's doing. He's hiding all his stuff. All his good stuff is at the bottom. He's trying to hide. That's all. He's all right.
Yeah. Well, he.
Yeah, he's all right. Unblock him.
Okay.
Yeah, he's okay. I see what he's doing.
Well, he's trying to pull some cryptic stuff, man. I don't know. But yeah, we do get trolls like that, man, and we just gotta get rid of them if we think they're a troll. So
right.
Yeah. Well, see, we don't know what the hell you're on about, GG. Why you lost your family? Well,
lost my family. I don't mind so much what happens. So, what country do you live in, GG? Australia.
Oh, that's why. Yeah, they need some energy over there. That's for damn sure. I bet your power bill's like fucking $900. Yeah. Yeah, y'all need this shit over there. Y'all should have it on. They already invented it in Australia, but your government suppressed it from you.
Yeah, what was his name?
You had a permanent magnet motor guy over there that had fucking, I think it was like 2 kilowatts cranking out. Yeah.
Have you done the GG? Have you done the Akula?
I don't know if he's listening or not. It looks like he's just typing.
Yeah. GG.
He could type. You can type if you gotta type. You could type one message. You know. That way it makes a little more sense because it's
instead of speaking to him. Yeah.
We're not really following what you're trying to tell us, buddy.
You know what? He doesn't. He doesn't understand English. That's what's going on.
You think so?
Yeah.
Well, no, they speak English over there. Yeah. Australians, it's English. It's just a different. I mean, they have different slang, but he can understand. He should be able to understand. They don't speak a different language over there. I don't think because that's inhabited by the English.
I can't understand it. I can't understand any Australian when they're talking like
I don't. Language now.
Okay, what type of message?
Yeah, I was gonna say they speak English. It's just they have a really interesting accent. I think of a kangaroo as soon as I hear one of them talk. I start to think about a kangaroo.
Yeah.
Yeah, did I tell you, Tim, that H told me that if you try to have designed the Howard Hughes or Howard whatever
Howard Johnson, yeah,
the weird shaped magnet, the horseshoe magnet that he had, they'll try to kill you, or somebody will come after you if you actually get the specs for that off his drawings and send off to a company to have it made. Hector said that you'll get a visit, or somebody will mess with you or try to kill you because they'll know what you're trying to do with it. And because that motor, I think he had like a 1.5 horsepower on a permanent magnet system, which is that's like. What is that, Tim?
No, his prototype, the last prototype he built supposedly was 540 horse.
What?
Yeah.
No way.
Yeah.
Holy shit! You're approaching the megawatt range, man.
Mm-hmm.
Well, maybe not, but you're approaching. Yeah, you are. You're about half 500 megawatts. or 500 kilowatts, isn't it?
500 horsepower. That's probably
That's at
150
least 500
kilohertz. 150 kilohertz. 150 kilowatts. Yeah. Probably.
That's a lot. That's
Yeah.
a lot of power.
Mm-hmm.
That would run a little neighborhood. You know, like 8 houses.
Easy. Yeah.
Yeah, and you could have a bunch of those. See, that's the thing. That's why we should have plastic houses, man. We could dip them, and they would be safe, and they would be safer than any other house you could have because they can be fire-resistant plastic. They can withstand storms. They can withstand floods. They can withstand wind. They can withstand everything, weather. I mean, and then you just replace it when it's done.
Yeah, fucking 3D print.
And get another one.
Yeah, you have
the
your
upgraded version.
3D print the home. You know.
Yeah, you could do that. Well, I'm saying you could even injection mold it so you could vacuum the walls.
Yes.
You maybe even do it with 3D printing, but if you make it like a thermos, and you could still have storage in the attic. Like you could still make it to where you can walk up there and it's still vacuum sealed, so you don't have to worry about insulation at all. You just pull a vacuum.
Right.
And if you lose a vacuum, they could patch it up, and then you pull a vacuum again, and then now you have a really like a thermos for a house. Literally, like it would be so cheap to heat and cool that. It would be like a 2-foot concrete for a house. You know what I mean? It would be almost, it might even be better than that. But, well, concrete's nice because it stays cool pretty much all the time. Or stays about the same temperature, especially if it's in the ground pretty deep. Yeah. Yeah, my dad has an old milk house on his property that's over 100 years old that stays cool even in the summer. It's like 80 degrees in there because of the rock.
Oh yeah.
And it was a creamery. Yeah, it was a creamery. They made butter in there back in the day because he's on a weird old farmland. It's not farmland anymore, but he's got weird water lines. And it's causing him problems now because they started busting. But there was a bunch of weird lines out there for the animals that we don't know about, and we don't know how far they go. It's weird, man. We can't even find them. We even had the water people try to help us find them, and they couldn't find them. They couldn't find them with the detectors, but they're deep. We don't know how deep they are.
So, are they coming from a spring somewhere? What's?
No. So what happened? My dad was living in this house, and he has a main water line going in, and the main water line also branched to the creamery, but it was disconnected.
Yep.
But the house branched off in the backyard, deep into the backyard, we believe, with several water lines for chickens and cattle back in the day. Like You're talking early 1900s, like 1920, 1930.
Yeah.
So we found checks in the house from that time that were getting written from someone living there. But so we think that they may be like 3 or 4 feet deep now because of the way the ground is moved. So the metal detector couldn't sense it probably. And we can't see it either. He let it run for 2 weeks because he didn't know at first when it broke, and he had like his water bill was insane.
I've got a metal detector, buddy.
He still couldn't find it.
I've got something. Hold on, I'll show you. I'll show you what I've got. I've got something. Next time I see you, I'll have to give it to you so you can try and find it. Does he still live there?
He still owns it. Yes. It would be nice if we could find it, but here's the one theory that I have that I hate to think about, but what if it's in the property behind us that got cut up? So It's not our property anymore. That belongs to us, but it may actually creep back there. We don't know. And that might have been why we couldn't find it, because it may be leaking on someone else's property. If that makes sense.
Yeah.
We don't know, because it probably might have been sold. Like, we don't know how much more the previous owner had that got chopped up when they put housing there. So it could even be like 3 doors down. We don't know. We don't know how many acreage this guy had. Because there's only 1 acre there now, and we assume there might have been about 5 to 10. So we don't know which direction or anything, But what do you got there? What is that?
So this is. I used to use this for my. I had 6 of these. They're like $3,000 a piece. And yeah, I used to have one in every box truck, every service truck. So what this does is it detects steel in the ground.
It's like pinpoint.
Yep. But this will see.
Hell yeah, dude! I'd try that. We try that out.
This will. No. This is special. This will detect. This will detect a railroad spike 30 feet in the ground.
shit.
Yes.
Oh, yes, Tim.
So this is what.
Tell my dad about that.
So the next time we meet up, I'll let you borrow this, and you can track that pipe to where it's going. Yeah, you'll find a lot of stuff. But it only locates steel. If you run into power, yeah, it probably is. It's probably zinc coated or galvanized pipe all the way up, guaranteed.
Yeah.
Yeah. But this is very sensitive. I can point this in the sky, zero it out, and wait for a plane to go by, and I can point this at the plane in the air, and get it and hear it. It'll go off.
What's in there in that device for it to be that sensitive? Sensor or what?
No, it actually what it does is it's actually kind of amazing how it even pulls off what it does, and I spent a lot of time looking at the circuit trying to figure it out. And
what's that cost today, you think?
Probably maybe $5 or $6 grand now. They've got a couple of models up from this one. This is probably I don't know, 15 years old maybe now.
Wow.
Yeah.
I
So
didn't know such a thing like that existed that could go that deep, man.
yeah. So what happens? What happens here is we've got two wires, two 14 gauge wires that go down here. It goes down the tube, and then there's a coil right here. So, and it just makes a loop and goes through the toroid one time. Oh, excuse me, no, not one time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times around. So you've got a thick winding on here that goes down to the tip, to the coil that's down here. Goes through this toroid. So there's 3 windings on this toroid. The real heavy one that does the metal detecting that's wrapped around the toroid. Then there's another one in here that's being pulsed. And then there's another winding that has the most wires on it. That's what goes to this op amp right here. So what's happening is it's pulsing this whole thing. It gets a read off the steel, and whatever flux comes back, this is picking it up. So it's not sensing the steel. It triggers a little magnetic field, focused at this end. The steel changes the resonance of this coil all the way to the toroid, and the balance, which is a discriminator like an FM discriminator. So any fluctuations, whether it be north pole or south pole, you can pick it up in here, and it'll show it in here on this meter. Yep. Because the meter is zeroed out.
So what's the mystery then? What is it? How they're modulating it and discovering it?
Yeah. Yeah.
How they're making it so sensitive?
Right.
And what are they measuring it against? So I guess this baseline, or no, you said it zeroes out.
Yeah, it zeroes out. There's no reference. Zero. Yeah, zero is.
So it's the analog then.
Yes.
Yeah.
Yep. Yep.
Dude, I wonder if we could make one actually, or you could probably modify. Actually, I'd leave that alone, but it probably works the way it is good. But imagine if you could figure out that coding, you could make a long one. I wonder how much more sensitive you could make it.
I don't know. I think this is probably as good as it's ever going to get for this, anyways, for this particular model. Yeah, it's sensitive. It's like you could be in an area where no metal around you, and point it at a car when they're going by, and the car is 100 feet away from you, and it'll go off.
Wow, dude.
Yeah,
that's insane.
It is. It's absolutely.
That's insane. How much you want to bet they have sensor arrays all over the ships in the ocean? How much you want to bet they got something 10 times more sensitive to that on those boats?
Oh, sure. I'm sure.
Because if you could detect a submarine with that from pretty good distance.
Yeah.
Maybe even far enough. If it's a magnetic field, let's see. That does penetrate. Yeah, a static field I think penetrates water.
Mm-hmm. Yep,
Yeah,
it does.
a static magnet field will penetrate almost anything once it's set up. It's the changing field that water stops or has
Yes.
it will suppress. Yeah. Yeah, I gotta download this on my channel. What's crazy though, Tim, is not a lot of people watch all these live streams. They'll just skip over it.
Right.
And they don't realize there's gold in it. Even the live that I did with Nathan had some nuggets in there that was pretty good. And this has got a lot of interesting stuff. I bet most of these viewers haven't seen. I know it looks like GG might have seen some of this, but I guarantee most people don't know about gravity detector, laser, spy, all this nutty stuff, man. And you got a lot more. I probably shouldn't say so.
And you know what? We have the United States. I don't know where is it. Is it in Arizona? I don't know if it's Arizona. Where's the interferometer? The government one.
For the gravity.
Yeah.
I don't know where they put it. I don't know.
Is it Nevada?
I think it's in Texas. Is it in Texas?
Is it Texas? I thought it was in Arizona.
No, it's not. The LIGO. You're talking about LIGO?
Yeah, the interferometer, the one that's shit. What the hell's the thing? 3 miles one way and 3 miles.
They call it LIGO, right? That's the name of it.
Yeah.
I can't remember where it's at. So yeah, but I know what you're talking about.
But I mean, that's a gravity detector, and look how that's a grand scale. Imagine.
I know that's massive. It's stupid.
Imagine what they hear.
They act like they don't know what gravity is, but I think they know. But I don't know.
I don't know.
Or they wouldn't have a stupid ass machine that big. It looks like a cyclotron.
Gravity.
Yeah,
I mean,
it looks stupid. It's like fucking miles long.
Yeah.
You know what I mean?
Yeah.
We can build a board that's the fucking that's the size of your phone.
Right.
Make one,
but it's a different process taking place. So that what they're doing is they're looking for a fluctuation in a laser beam. You know,
oh yes. Yeah.
You know what I mean? And they're looking for like a millimeter movement. You know.
Yeah, that's only gonna pick up. That's only gonna pick up the big ones, like the supernova, and it's just barely perturbing that laser.
But I truly think that, if the gravity wave is going right through all of us, that's same wave, you know what I mean? We just happen to be in a way. So whatever direction it's coming from, we should still be able at the end of the day, even just a small little capacitor is.
Damn it, Tim! I guess I got the small package on the damn op amp. God dang it! I can't really look at that. I mean, I'd have to get an SMD board. I know how to solder that, but I can't. I'd have to have a pad. What's this? I thought I looked at the picture. I thought that I got the bigger one. Sometimes they send me the wrong shit. But there's a small one too.
GG, what are you working on these days?
Oh, I could probably wire to that. Yeah, I could wire. Now that one I can. What is this? That's an op amp. Okay, I got the op amp. And then this is the op amp, high speed operate op amp. This is the one I think that I've got to use. Man, this is a small. God dang it. I can't remember why I did that. It was on sale or something.
Oh, you got the surface mount?
Oh, God, yes. It's so small, man. I can do it. I can do it. I got some wires that I can do this with.
Hey, you can buy.
Damn it!
Did you see those little? I saw them on
Yes,
Amazon.
Circuit board and solder it on there with a plate. I got this paste. Yes, I could do that.
No. No. Picture an IC chip, an 8-pin IC, without the chip. Yeah. It's just the base, and you put the surface mount on that and solder it in, and then it plugs into an 8-pin DIN.
Yeah. I'm sure they make a board too.
Yeah, I've seen them.
You know what I mean?
Yep.
Yeah, I can get some of those. That's what I'll do. Because that one's a good one, man. That was expensive, so I'm gonna use those. Because when I made my flashlight, I had to do the same thing. I had to heat a piece of aluminum with a torch, and I put the paste on it, and it was easy. It wicked right on there, no problem. Like it was real simple. Like it welded itself. I didn't have to do shit. All it didn't heat it up the right temperature. But as soon as it was the right temperature, it wicked itself on there. It was pretty cool to watch. I almost couldn't believe it that they could do that. And it won't be that easy. You know what I mean? Because it was real easy to put on. Yeah.
I wonder, we've got 4 people in here?
Yeah, it fluctuates. There was 9. I think it changes when they're either just checking it out for a minute and exiting, or they're backing it up to where it's not live anymore, and I think it might take it off. I don't know. It seems like, because I've seen people come in real quick and then it drops back like they're rewinding it or something.
Oh.
But who knows? Because they we didn't announce this, Tim. That's the thing. We just did it randomly. So
yeah, we'll have to do.
Right? But it's staying. If this is the good stuff, though, because a lot of people haven't heard you talk very much lately in years, really. You know what I mean? You haven't made that many videos that you talk about. What have you got there? Oh yes, I seen those when I was at your house, I think.
This is the other one. I haven't done anything with them yet. I just started playing with a little, and it's like I got to get cracking on it, because this has got what do we have here? We've got it's a step down to 120.
Yes.
So
I remember. I'm jealous.
So we got 2. I can't read this thing, so gotta get my magnifying glass out. So it's gonna get real bright for a second. Yeah, so we got 100, 440, 460, 480, 500. So that's one high side from 0 to 100, and then from 100 to 440, 460, 480, 500. And then we have 120, 240 times 3 for 3 poles. And then that's it. So that gives me on, let me shut that light off because that's just way too bright now. That gives me 1, 2, 3, yeah, so 4. So there's 4 different winding configurations that I can do to make that work, coming in and going out. Yeah, but I think initially what I want to do is use that other one to drive this one. So I want to run this one the way Hector likes to run his.
Yeah.
And make it squeal like a fucking pig. Yeah. Make that thing whine and squeal until all the piggy fat comes running out of its ass.
Yeah, foolish cunts out.
Yeah. So.
Shuts and cunts.
Yep, that's Hector's terminology. So. Yeah, this is a beautiful transformer. So I want to use the other bit to drive this one.
Yes.
Yeah.
Yes.
And then see what I can get to. So, yeah. So ultimately, I'll bring the board up. Yeah, started to do a base. So I got these caps are the 100,000 25-volt caps, and so I want to have that on here. Put this guy on here, and we'll have an inverter on here. Put an inverter over here, and then ultimately, I think I'm going to be doing is turning it this way, because I'm probably going to put another row of caps in here. I'll save this room in here for tuning these guys with the AC caps, and then the inverter will be down here on this end. And
Okay, so hold up. You're gonna try to invert and loop it.
yeah,
Okay.
yep,
So you're gonna bid it and then isolate it with the big one, and you're gonna cap it.
yeah,
Okay.
yeah, yeah. Because based everything the way I saw that thing act when I was using the bit to run the battery, to run the switching power supply to charge the storage batteries, to keep the inverter running. So I had two inverters running. One was just to run that. That's it. And then that ran the switching power supply, and that fed the battery. And then the other inverter, the 600 out of the 1200 watt inverter I had, that was split off with an extension cord leaving here, going inside. And I had that plugged into the refrigerator and to the TV in the living room, and a few lights and a couple of fans. Got me for 3 days that way. Now, it's only 200 amp hour of storage. That's not a lot of storage, not for 3 days. You know what I mean?
Yeah.
And I was I got to the point where it's like, yeah, I can't believe this. This is just too good to be true, too simple, because I just threw it together, and it's like, this isn't. I'm being fooled. And so I shut the inverter off, going to this, charging the battery system, and I started to see it going down after a couple hours. And it's like, whoa, this is doing something. So I turn that back on, and I go and check the battery volts a couple hours later, and I'm back up to 13.8. You know?
Oh yeah.
So it's like, all right, this is charging it. There's no way. There's no other way of figuring. There's no other way to look at it. It's charging it. So. Yeah. So imagine getting an advantage on that one, and then driving this one, and then taking that output. Yeah. So it'll be interesting to see. That's the plan.
You had some fairly decent sized caps on that bit that you were looping back. Yeah. You were resonating it.
Yeah, that's all those.
Like you had some caps in there.
Yeah. Yep. Yeah, 10 UF for these two coils in series with 10 UF across, parallel to these two guys being in series. So one cap needs to resonate that. Take that AC, and dump that into and it's just running the switching power supply. That's it. That's all it was doing. It wasn't doing anything else. Yep.
And the switching power supply is meant for 120 volt.
Yeah.
Yeah. Okay.
Yep. Yeah, it's I bought it on Banggood, so it's adjustable voltage all the way up to, I think, I don't know, 14.2 or something, 50 amps. So it's a 50 amp switching power supply that I wanted to use to charge that, and so that's what I ran. And what was I measured? What was I getting? I think I saw like 14 to the batteries.
Wow.
Yeah, 14 amps going into the batteries. Yeah. Or right around there. Sometimes it was 17. Sometimes I saw 20 something. But it was doing it. It was producing it, and it was feeding it right back in. And it didn't seem to be, obviously, if I was taking the power to run the inverter straight from the batteries, to run a battery charger, I'm not gaining anything because there's no advantage. You know what I mean? But huge advantage when you put a bit, when you put the bit in between them, it's different. Yeah, you're doing something.
I remember what it did to the other one, the other machine.
Yeah. Oh, running away. Yeah.
Yeah.
The runaway.
Yeah, that fucker tried to run away. Yeah, I know. So when I did my bit, I think I've still got it somewhere, but I think I lost the shunt things I had. But I was reducing voltage at like 99% efficiency, which was kind of crazy. Like it was a reduction transformer that was under load, reducing at 99% efficient, and I was rectifying the output. So I know the power factor didn't matter. So early, well, I guess the power factor going in, but it was off the grid, so it shouldn't have been shifted at all. So what I was measuring should have been accurate. Uh, so it was like 99. I was like, that's kind of, it wasn't over 100 for me, but the reduction in voltage was pretty amazing because it cut the voltage in half at 99% efficiency, which there's not very many things that can do that other than an MPPT or some switching boards now they have, but I was amazed by that, Tim, because that's isolation for one. It's isolation for you, and it can reduce the voltage of something that maybe your voltage is too high, like the bit, 120 volts. Imagine if you put it into another bit to reduce it to 60, then you could just rectify it, send it into an MPPT board, and charge the battery more directly than the power supply. I don't know. What do you think the efficiency is of that power supply?
It's got to be pretty good. I mean, it's a switching power supply. You always when you use a switching power supply, you're going for that efficiency. You know what I mean?
Yeah, and you know what, Tim? You can actually do that with your setup right there. That big transformer, just split those phases. I don't know if you're going to send it into the middle coil, split the phase, so you can collect 50% of the voltage on one side or both paralleled, and it's like a step down, but it's much more efficient for some reason since it's splitting. Since it's going in a toroid now complete.
Yeah.
I don't know what it is about it, but with the shunt bars on it too, it was super efficient. I think it's because of the way we were describing the flux path. I think it's just bouncing off itself, and it's kind of assisting.
Right.
It's assisting the next cycle, and to the point where it's dancing with the AC power line or whatever, your inverter or whatever.
Mm-hmm.
It's just dancing with it, so it's allowing you to kind of bounce with nature, or something to that effect, becoming a feed-forward system.
Yeah, when I first got this transformer, I literally tried to run. I tried to pretend that's a 3-phase motor. Just think of it as a 3-phase motor.
Yeah.
With no noise. Yeah.
Damn, are those 25 volt caps? Where do you get those caps?
These I got from I got these from a repeater power supply.
Okay.
Yeah.
Nice. What are they? What are they? 15,000 UF?
No, 100,000 20 volt, 100,000 20 volt.
Oh well, are you seriesing or what are you doing?
All parallel. Yeah.
Oh, for the battery. That's your battery. I see.
Yeah.
I see. It's your super cap, basically.
Yeah, pretty much.
Make essentially a super cap that has a little lower loss because.
Yeah, I don't even know what the ESR.
Voltage caps collects.
I don't even know what my ESR meter stopped working, so I don't even know what I have on here.
Well, the thing is, even Akula said that your voltage, the cap voltage, needs to be at least higher than 63 if you want to try to catch more of the radiant in the systems. You gotta use a higher voltage cap. But those, since if you're only putting out 14 volts, that's going to be a nice buffer.
Yeah.
To go into your battery and smoothing out the ripple, and it's going to catch any little transient, especially if you're already at that voltage. I mean, that's nice. I got super caps in too. I got some for the thing I was telling you I'm building. I can't talk about that right now, but
yeah.
That might be in trouble with now. But yeah. Oh. That's cool, man. You got so much stuff, man. My God.
Yeah, I had too much stuff. I had more.
Have you seen the racks that hang from the ceiling, Tim?
Yeah,
You should get some of those.
I'd
Even
like
if
to,
it's
but
just one.
I don't know if I'm staying here. You know what I mean? I don't know if I really don't want to move again for a while. But this company was
Didn't
just.
you buy that place though?
I don't know if I'd buy this place. It's like
Oh, I see.
this.
Okay.
This like so many things about this house that they did. That's it's a builder special. Yeah,
I see.
yeah. But I mean, it's still a great house. But
Yeah, it looks nice.
they want too much money for it, and the company that I'm renting from is like we've changed hands ownership. This is I think 3 times now. Different company keeps selling out to somebody else, and they own a bunch of houses all over the country.
Yeah, are you talking about moving to another location around there?
Yeah, I know I'll have to stick around here. I don't want to move at all, but I don't know if they're gonna jack their rent up on me and keep going, then I'm not gonna stay here because they're out of their minds if I'm gonna do that. Yeah,
Yeah.
it's like almost at the point now where I'm paying too much.
Man, you should find a place out in the country a little bit further to drive to work, but one that's got like a barn or something for you to set up in, or a shop, or or another garage. That's all I want.
Yeah,
That's a nice garage you got at that house, though. I mean,
yeah,
it could be bigger, but it's still a decent size.
yes, yeah. It works fine. It's works fine for what we're doing here. But I mean, if they come and say they're gonna jack it up another $100 or $200, and it's like I'm gonna tell them to fuck off.
Well, yeah, real estate's actually coming down. And I know in Denton, the rent's coming down a little bit on houses and stuff. It's
Yeah.
come down about $200 to $300 on average so far on the rent houses. On apartments, it's like 100, 150.
Yeah, we've seen
houses come down.
we've seen Joel LaGrace. He's he does a lot of stuff. Seems to be preoccupied in his comments a lot. It's like, you worry about that on your channel?
What about what now?
People saying shit.
Nobody's said much other than I've had a few. No, you can actually block keywords if you want.
Yeah.
If you want to block cuss words or certain words, you can. And then
No, I'm talking about like the trolls and shit. And you got these people that come
I
on.
block them right away. No,
Yeah.
I just block them. But I only had maybe 2 in the past couple of years. Most of them that I block or delete are kind of stupid comments. They're comments that obviously they didn't watch the whole video or they're not paying attention to something before that. So it just doesn't make. It's like you're repeating what I already said. So it's like, why are you saying it? And then I'll usually respond and tell them, and I'll give it a couple hours so they can see it, and then I'll remove it because it's relevant. Because you said the same thing I've already said in the videos multiple times. So it's like, those, yeah, I delete because it's irrelevant. Now, the comments that add stuff or add the message I'm trying to get out, I'll leave and talk to them. And if they're polite, But if they say something stupid that's like obvious, like if you're, you should have probably looked into the project a little more if you want to comment on it like that, then I'm going to probably eventually remove it because it's irrelevant to be on there. It just confuses people that are watching it and trying to pay attention. It just confuses them to see that again.
Yeah.
Because it makes them think, well, why is he doing the project? And it's like, but if you would have watched, I would explain that I'm not doing it for the generator. I'm doing it for the ECMs. I don't care about the generator that much. The only thing that generator will do for me is be an emergency last resort to my inverter system or to run my little welder out in the field. And I'll set the welder on top of the damn thing and I'll just weld off of it. And it'll be on wheels. So it'll be perfect. It'll be lighter than my big welder and able to weld 240. So I'll have quite a bit of amps available. I think the whole capacity of that welder, or damn near all of it. About 150, I can crank out 150, 160 amps with it on a stick. So I can build, anything with it.
Yep.
So fence, and I ordered a DC electric post hole digger that has handlebars, but I'm going to weld a wheel for it. You know what I mean? So you can set it down on the wheel and it doesn't turn on you. Because I thought, I'm not going to pay extra. Because there was another one that was gas. It was a 2-stroke. I didn't want 2-stroke. I didn't want gas anyway, because electric's better. If the shit hits the fan, it's going to be a lot better to have electric. Because there's stuff you can do, you know what I mean? To make work, if you had to. Versus gas, you're limited. You're going to have to, try to make some kind of wood gas or some bullshit.
Hey, how long do you think those little turbines last?
What turbines?
The little micro turbine generator packets.
You talking about like for like a house or something?
No, they've got some for. I've seen some that are like.
Well, if it's brushless, technically, as long as the diodes hold up, I mean, because it's it's like a drone motor.
No, I mean the mini turbine, the gas turbine. It's turning at like 300,000 or 400,000 RPM. That's like, I wonder just how long, even though it's pressure lubrication and all that and cooling. And it's like, just really at the end of the day, I wonder how long they last.
Well, they run on if my grandfather was alive, he'd tell you all about it. But I think it's, they got a service that I know that. I have an aunt. She's actually my cousin, but she's old. She used to do the maintenance. She was over maintenance. She had to put in the part numbers of stuff and order stuff for the engines. And I know they had to go through service every so many hours. It was a very big deal. And then they burn oil a lot of times for their lubricant. So it's it's kind of like a turbo on a car.
Yeah.
You know what I mean?
Yeah.
And it doesn't burn a lot of oil, but it's using a little oil. Probably it's probably oil bearings, slip bearings.
Yeah, I seen one turbine set up, and it looks like it's a Cummins turbo that they used, but the actual connection and the way it generates electricity is another turbo in line with the inlet that has a brushless alternator on it. So the brushless alternator is never near heat. It's not at the hot end; it's at the cold end.
Right.
Yeah.
That's actually pretty ingenious because that brushless DC motor is going to be very reliable and very efficient. So you're getting most of your power as long as you can have a high efficiency on your turbine. You got it fucking made, dude. And then you could stick that in a drone. You could stick that in a car. You could stick that in a plane. You could stick that on whatever you want, man, and get a long range. Like 8 to 10, 12 hours. Pretty easy on a drone. You can pull that off pretty easy. You could probably pull it off with a little baby Perkins diesel that's tuned right. You could probably pull it off with that if it was an aluminum block. I mean, I don't know if they make them, but I'm sure the military could probably make them. But make a really lightweight engine that can run really efficiently for a long time. Like imagine a little inverter generator that runs on diesel that has a decent sized fuel tank on it. It'd probably run for 8 hours at least, generating full power.
Yeah.
And you don't need that much. I mean, a few thousand watts is probably all you need to keep that thing in the air. I doubt it's, a lot, like a lot. Or they just put a bigger generator, because some of them are the size of vans and shit. Those we think are running on something a little different. Yeah. Technically, they could have been battery powered too, some of them, because there's some battery chemistries that are slowly coming out now that have already been in the military for a while that have a much higher power density, so that's not that far-fetched either, just for it to have a damn battery. Because Elon, there was rumors about him releasing the battery for his Teslas because it was better. It was like 10 times more better energy density, and then it charged faster, and it lasted like 50 to 100 years or some shit like this. And it had no rare earth elements either.
Mm-hmm.
It had all common elements, and I can't find the article. My dad was he showed me at his house, and I can't find it, but yeah, it was amazing battery chemistry that they're coming out with. So
sodium based, I thought.
Yes, I think it might be. Yes, I think it might be, and it's. I think it might have lithium still in it, but lithium's in the ocean. It's not. Lithium's not the really hard element to get. It's the. There's, I think, cobalt is a rough one. There's a couple elements in those batteries that's hard to get, and I don't know if they can extract lithium from seawater that well yet. Do you know about that, Tim?
Yeah. I don't know.
They have to pump it out into a plant, not do it, near the ocean. They probably have to pump it out.
I don't even know how would you even do that?
Well, because there's gold, there's lithium in the ocean water.
Yeah.
You remember Sajaka's magnet?
Yeah.
I think that there's some secrets in that too that being employed by certain countries. But yeah, that's a really interesting. And it ran on DC. Remember?
Yep.
The Sajaka magnet, it was DC. So what the hell's going on, man? It's something in the core. It's like, what?
Yeah.
So I don't know what it is, man.
So you got a static. I don't believe it was static neither. There was some kind of something going on with an oscillation or something.
That's what I thought, man. I'm like, well, I think it was PWM. I can't remember if it was PWM DC or if it was straight up DC, but there is, it creates a magnetic field, but I don't know what it would do, but maybe I should try to make one sometime.
Yeah, they had to been. They was being pulsed with a square wave, guaranteed. It had to be. Yeah.
Yeah, something didn't make any sense because I could see it if you could resonate the core or if your magnet at the resonant frequency of gold. I could see that maybe attracting it, but other static field, I just can't wrap my head around how the shape of your core and a static field will pick up gold.
Mm-hmm.
So yeah, I feel like something's got to resonate because I know if you get in resonance, you can do it. You can also extract minerals other ways with that technique.
Yeah.
So yeah, and you know what else is crazy is remember we were talking about, we can get this on the live because this is interesting. People will freak out when especially if they, because I ordered a Microsoft Encarta CD. And then I told you about where in the Encarta they were talking about how they found, and this was Microsoft Encarta. It was a certain year, I think 87 or 86 physics, and they're talking about finding trace element 115 trace amounts it was a meteor crash, and then or something. Yeah, it was in the ocean, and then it was a meteor impact site where they found some, and then stable. It was stable, like Lazar said. And then I told you about it, and you said, yeah, they actually found some too on some of the failed fusion reactor experiments. I think it was you that told me that.
Yeah.
Wasn't it, Tim? Yeah, they found some of it on that. And it's like, oh, did you really? Did you really now? Oh, you tried to fuse some elements together and you ended up getting a little something. That's interesting. And all you did was put two things together under current, under a field. A big one, but real big. But I'm sure it's bigger than what we could probably manage, except if we had a very, very tiny little vessel. But it'd be interesting. And there was something else, wasn't there? Because they found it somewhere else too. I can't remember. Oh, they found it in the nuclear reactors, didn't they? Just in the normal nuclear reactors or something?
Oh, that I don't know about.
It seems like I heard that too, that they found some in trace. It was like something was happening in the reactor, and there was very trace amounts of other elements. It was weird. I can't remember where I was reading that, so I don't know if it's true or not. I can't remember because I'd have to see it again to make sure that was right. But yeah, it's pretty crazy. I know that it's in the Encarta where they found some, and then which proves it's stable. So that's kind of crazy. And then the fusion experiment that when was that, in the mid 2000s?
Yeah, I think so. No.
Yeah.
Before.
You can't find that anymore.
It was before 9/11. Before 9/11.
Oh, okay.
It was.
Was it in Japan?
No, it was here in the States. It was before 9/11 when they did it.
Wow.
Yeah.
How did you hear about that? Was it on the news or in the magazine?
Actually, it was who was talking about it? Coast to Coast AM. Did I hear it was the first time? I think Coast to Coast AM was one source when they were talking about the college over at west of me. What the hell is that college there? Austin. In Austin, Texas. There's a college there, university. They did the experiment there, the cold fusion experiment. They said they found traces of it there on their experiment. And then MIT said this. MIT verified it. They said they saw the same thing. They discovered the same thing.
Yeah, man. So they're creating elements, and I bet we've been making that stuff.
Yeah, exactly. For it to show up like that.
I don't think they don't hear about that stuff, man.
Right.
They don't hear about those little things about them discovering it on reactors and shit like that. That stuff that basically it's saying that we discovered it on accident. Oh, that's another story we need to get on film before we end this, Tim, because I'm already past due. I want to remember. I think I told you about the ultra low NOx burner at John Zink that they discovered. John, the engineer, discovered it on accident. So they were John. He doesn't have a degree either. He's an incredible engineer because he got in an accident and they made a settlement where he actually got a nice office. Anyway, so before then he was a test operator and he was at the John Zink test site in Tulsa, Oklahoma. They had a test site that looked like a little baby refinery. It had some of our stuff on it, like flare tips and pilots and all kinds of stuff that we sell to refineries all over the world, or sold. I don't work there anymore, but anyway, so this little baby refinery, it has different gas, all the gas that refineries have, and certain setups like boilers and stuff. But anyway, so these two operators were in there, and John was one of them, and this was before he was a real engineer, but he was in there, and they were just fucking off. They were fucking off with the controls, like dumping nitrogen, they were dumping hydrogen, changing the mix, they were all kind, and they had some of the most advanced sensors in that tunnel system, because it was a test tunnel. They had this burner in, and they're just playing, right? They're just messing around, having fun, and all of a sudden they hit a certain spot they were messing around, and they started to hear a little bit of a hum, and then the flame went out, or the visibility of the flame was gone. And then they also looked at the NOx meter, and it went down to 0, or pretty much 0 on the meter. So they had looked at each other and said, I guess we put it out. Well, then they look at the other meters, and the temperature starts to climb. And lo and behold, there was still a flame, but it went completely invisible. It started to burn completely invisible to the eye. And this is a high heat. You're talking probably 50 to 100 million BTU hours coming out of this thing. So, or more, because I don't know exactly the size of this thing, but we had incinerators that were incredible amounts of heat. And so what had happened is they stumbled in, and then it became unstable or something, and it shut off. And then they managed to recreate it, and they made a few phone calls, and the next thing you know, because we were the headquarters for John Zink, but we're worldwide. So there's plants. There was a plant in Houston. I think there's one plant near you. Flint Hills is also owned by basically John Zink. It's owned by Coke, which we send stuff to Flint Hills all the time. But Flint Hills refinery down there owned by Coke. But yeah, so that burner after they discovered it, a bunch of bigwigs flew in to Tulsa, and the next thing you know, they talked about it. The next thing you know, they patented it, and that's now they called it the ultra low NOx. I think it's a burner. I think it might be a thermal oxidizer, but you guys can Google that and look at it. They got diagrams of it. You can look at it, and it's like damn near 0 NOx, which is essentially telling you how clean it's burning, which is telling you that we've been able to burn our hydrocarbons at a nearly 100% or clean burn for a long time, ever since that patent was filed. And they've already had clean, low NOx stuff. But yeah, we've definitely been able to make nearly 0 emission burn for a long time, which is kind of strange when you look around and you don't see a lot of it. But yet the technology definitely exists. I don't know if they have a monopoly or if maybe their patents are blocking, other people from doing it. But yeah, and they also had a pilot that could light underwater, the AG2. It's on YouTube as well. Very, very hard to pull off because the pressure swings it has to deal with, and it can light underwater and stay lit. Then we made a pilot. It was called a Hurricane pilot. I think it was 2 million BTU hour. The AG2 was also 500,000. I think it was a little smaller, but it could light underwater, stay lit. The Hurricane pilot was bigger, but it could withstand 350 mile an hour hurricane force winds with rain. They would pump rain in there too, and it would stay lit because all those flares would have to stay lit. If they went out, they'd start getting fined because of all the raw gas you're pumping, because that's like a garbage disposal, all the flares on refineries. Anyway, I just wanted to tell you that story because, there's a lot of technology that people really don't know about that like clean burning stuff. All of our power generation plants should be 0 NOx by now, all of them. So there really shouldn't be any complaints about the carbon getting, you know what I mean, or any of the toxins, nitrous oxide, all the bad shit getting into the atmosphere, because we should be able to burn it nearly basically 0. I mean, so small that it's so much better than what we're doing right now. It's crazy overall in the world, because you can't, like John Zink, they're not everybody's going to buy those, and then so it's like it just needs to be like mandatory or something, because it would clean up a lot of the areas where it's smoggy if we started implementing that. I don't know how you could do it in cars. You probably could. Well, I'm sure you can. Like the thunderstorm generator does it. It turns everything. It slams it into oxygen. It turns your exhaust basically into water. Do you know that, Tim?
Really?
I bet that yes, the thunderstorm generator will basically make it to where you can run that combustion engine in a garage, because it removes all it removes other stuff, and it brings the oxygen back up to normal breathable levels. So it's actually kind of wild that it even works. But it's a plasmoid in there dancing around and collecting energy and exchanging it, and it feeds back to, there's something else going on, and you have to put water in it. But yeah, all you got to do is add water, and I think it actually adds horsepower or something to that effect. It does something, and it runs off the exhaust heat. That's what causes the reaction to start, or it helps it.
Right.
So it's actually using the engine's waste heat
to
start the reaction.
It's the GEAT system,
great.
yeah.
And it should be mandatory. Like, forget the catalytic converter. I mean, you should have that thing on there, and have it modernized, and have scientists do it to where it's like fucking looks like what it's supposed to look like. It looks like a high technology, and then you bolt it on, and then you're done.
Yeah.
And it doesn't have to look janky like you built it in a garage. They can make it look like it should be on a space shuttle if they wanted to. You know what I mean? They could make a nice one. If scientists had it in a lab and they studied it, they could have that fucker working. They could have it small. They could have it compact. They could have them on motorcycles. They could have them on everything.
What makes you think that they don't have it on stuff?
Well, I know they don't have that. I mean, I think Honda or somebody, or no, it wasn't Honda. Who was it? Actually tried to partner with that guy. It was an overseas car maker, I think, actually. But someone tried to they were interested in it. Something to do with their hydrogen car, too, I think. I don't know. It was something to do with the hydrogen car, and they were interested in it because it could help that somehow. I don't know. Something like that. Maybe because it already had water. I don't know. There's something to do with that. Because the hydrogen car actually had an internal combustion engine. It was just, at least the one that I'm thinking. Or basically it would burn it. So it would, can't remember. Because they had an electric one, and then they had the regular engine anyway.
I would like to see the system where, I saw there was somebody on eBay selling the whole kit for 5-horse Brazen Stratton. And
for what now? A hydrogen kit?
A whole kit, yeah.
Yeah, that's tough, man, because you gotta, I don't know what you can inhibit rust with on the engine. What do you do to inhibit rust?
No. The kit, the whole kit, the GEAT kit.
Oh, it heats it and everything?
Yes. The whole setup,
so.
the whole setup for the manifold, for the intake, and for the exhaust. It all bolted on a 5-horse Briggs & Stratton. This kit I saw on eBay, where it was going to run like that. The GEAT system.
Yes. No shit.
Yeah. for a while, and then all of a sudden, and you know the shit that they had in the eBay store. It's like I wonder if it was a woman or something, and she was selling the shit for somebody because she's got a lot of craft stuff on there, and nothing like that, you know.
Yeah, that's kind of weird.
Yeah.
I want to see.
Hey, this was going to be my V2, my version 2 gravity wave detector that I never finished.
Oh.
I was looking for my other one that I have another one that's in the same exact case. That's just got that in it, and it's nicely shielded and everything, but I can't find it. I don't know. I gotta keep digging. But this was my other one that I was starting to build, and this was going to be tunable. This was going to be tunable in frequency. Yeah, it was going to be nice. I gotta finish it. I've been like looking at it.
Yeah, you gotta finish that thing, dude.
Yeah.
Because that's that could be the next generation UFO detector.
Yeah, it'll be simpler than that.
Yeah, might even be able to detect them from a couple miles away, a couple 100 miles away, maybe.
Well, I mean, gravity waves.
I don't even know. I don't think it's really a wave because they say it's unipolar, but it is an oscillation, so it's kind of hard to imagine. But I can kind of see it. But technically, if you have a sensitive enough probe, you might be able to pick it up from almost any distance, right?
That's what I'm thinking. I don't think I don't think it really matters where you are. Does it really matter where you are in space?
I mean, we pick up supernovas with it.
Right.
So I mean, those, you know how far those away. We don't know how the time, like, I guess, so you don't know how long it took to get there. But.
Well, I mean, if you look at entanglement, I mean, is there something like that going on at the same time, or is it literally a wave? Is it literally?
Yeah, I'm not sure. I don't think it's a wave. I think it's unipolar. But I'm about to have to go.
Yeah.
Tim.
Okay. Same here.
So, all right, Tim. Let's wrap this up, and then I'm gonna download this so I can put it up on my channel too.
There's gonna be I need a big hard drive, man. There's gonna be. Oof.
Yeah, I know. We went for a while. Okay, man. I'll talk to you later. I'll talk to you tomorrow.
All right, buddy. Have a good one.
All right.
Anybody else out there? Have a good night. Thanks for coming.
Yeah, y'all too. Peace.
Peace. Hey, GG. Thanks for coming up, buddy. Yeah, everything is connected. I agree. Yeah. No, I agree. The whole world should be thinking about doing that. Let's wire is a great way to keep increasing efficiency. The more conductors, the better. We all work together on it. All right, GG, I'm going to get out of here. Anybody else that's on here? What do we got? 4 people still. I'm going to shut this thing down. Tomorrow's $1,000 a day. Y'all have a nice evening. Thanks for coming. Catch you again soon.